Good morning and welcome to our live ATS webcast seminar, Built to Last Durable Design Solutions. I'm Fulgence and I'm your moderator for today. I'm also accompanied by our team who will support us throughout the event. Today we have 5 courses with 2 breaks, and it's my job to let you know exactly where we are throughout the day. So you'll see me pop up after each speaker and make sure our speakers start and stop on time. And if you're having any technical difficulties, try logging out and then back in. That normally resolves most technical glitches. But if it doesn't resolve that, please let us know in the Q&A panel. And if you happen to be in a conference room watching with a colleague or at home watching with a partner, please make sure you're each logged in with your assigned Zoom webinar link. That link is attached to your ATS account, which is how we report credit on your behalf. So if you have not done so, please take some time now to log into a separate device or a second window so we can make sure you get the credits that you deserve. Please also know that we will launch poll questions during every presentation, and we ask that you participate in those polls so we can confirm your attendance. Let's go over a few quick housekeeping notes to help you get the most out of today's session. Please use the Q&A panel only for all questions. Please do not submit questions in the general chat. We need you to submit in the Q&A panel so they can be included in the Q&A report. Also, we kindly ask that you do not post any questions anonymously, as we are unable to verify your attendance for credit purposes when questions come in without a name attached. Please also note that this broadcast is also live on YouTube. The link is in the general chat. However, we ask that you remain in the Zoom webinar to participate in the polls and the Q&A. But for your viewing pleasure, you can check it out on YouTube. Today's seminar features 5 AIA HSW, 2 GBCI, 5 AIBD Primary, and is valid for the following Canadian provinces. We will report AIA, GBCI, and AIBC credits on your behalf within 10 business days. And if you're a member of AIA, GBCI, or AIBC, please double check to make sure that your association numbers in your ATS account are accurate so we can ensure a smooth crediting process. And for everything else, you get a certificate in PDF form. That is 1 certificate for every course you take with us today. And those will be available immediately after entering your session code. So if you're new to the session code process, I'll review that after our very first speaker. And where can you find those certificates? Once you log into your ATS account at atsseminar.com, you will click certificates on the left. Then you'll see all the courses you've taken here at ATS. And to the right of that, you'll see a small certificate icon. When you click on that, your certificate will pop up and it will look something like this. Also, handouts from today's speakers are available for download from your ATS account dashboard. And again, if you're new to this, I'll explain how to access your dashboard after the first presentation. And with that, please help me welcome Cassandra from Penetron for benefits of impermeable concrete utilizing crystalline technology. Cassandra, hello, how are you?
Good morning, Fulgence. I'm doing very well, thanks. And you?
Good morning, I'm doing great. Great to have you here.
Good, thank you. Can I share my screen so long?
Yes, please.
Okay.
All right, Cassandra,
Hey, can you just see my presentation slide?
yes, you are all set. Take it away.
Awesome. Well, thank you so much, Fulgence, and the ATS team for the opportunity to be able to present on the benefits of impermeable concrete utilizing the crystalline technology. And with that, welcome everybody. I know it's still early, so I hope everybody's got their coffee and ready for the presentation today. I really hope that you're going to find it interesting and informative, and that you'll be able to use some of this information in your day-to-day designs. But before I start, let me just introduce myself. My name is Cassandra Goos. I am a civil engineer and the technical manager for Penetron USA. A little bit of background. If you haven't figured out my accent yet, I was born and raised in South Africa. And after studying, I started my civil engineering career in the consulting industry, designing bridges and culverts. And then I decided to specialize in water retaining design. I did that for a few years, and that's when Penetron in the US, Penetron in South Africa, excuse me, approached me to become their technical manager. I worked for them for 5 years before having the opportunity to be moved to the Penetron USA team, and I've been with them for 7 years now. So hopefully I can share quite a bit of my experience and knowledge that I've picked up over the years with all of you today. Now, as Fulgens mentioned, today's presentation is an AIA registered presentation, meaning I'm going to keep everything generic to the crystalline waterproofing technology. But please take note that the test results that I'm going to be sharing with you today will be based on the Penetron product range. And then I'll just end off the presentation with a few Penetron slides, just introducing some of the products to you, and then I'll follow up with an email so that you can have links to our website. Now, today's presentation is going to be on the crystalline technology mainly. It's going to explain how it works within concrete and how it decreases the permeability of your concrete to overall give you an increase in the durability and service life. And during this discussion, we're going to take a look at concrete as a whole, the deterioration factors, and how the technology can mitigate those deterioration factors. And then we'll also end off, or during the presentation, by discussing some of the ways on how this technology can actually streamline your project costs and actually fast track your construction schedules. So today's presentation is valid for one learning unit as well as an HSW, or I suppose. And for us to be able to offer you that, we have this quote from the Concrete Engineer's Handbook back from 1918, which states water penetration is directly or indirectly the cause of the majority of disintegrations in concrete, and the degree to which water penetration is permitted by the texture of any concrete is a direct measure of its strength and endurance. So when your concrete cracks and it allows water in to your habitable spaces, that causes moisture and imperfect conditions for mold, mildew and things like that, which could affect your health. So by stopping water from getting into your habitable spaces in the first place will give you a healthier environment. Now, after today's presentation, you'll be able to analyze the makeup of concrete, the main causes of concrete deterioration. You'll be able to describe how the crystalline waterproofing technology works, as well as its benefits when you're incorporating it into your concrete, be it new concrete or concrete repairs. And then we'll explore a few different applications of the technology and how I'll show you how it then increases the durability and the service life of your concrete. So let's start at the beginning. Crystalline technology works with concrete. So concrete as an element is made up of sand, cement, gravel, also known as aggregate, water, and most concrete now has a bunch of additives added to it. Now, the water that's added to your concrete is added for two reasons. And the most important reason is the fact that it hydrates the cement particles. And when it hydrates the cement particles and it sets, it forms that hard paste, or the paste that glues all the other elements together. And then it forms this hard substance that we know as concrete, right? But about 60% of the water that's added to the concrete when you're mixing it is purely added for workability. So when you've placed your concrete into the forms and you vibrated it and it starts to harden, it starts to cure, then the excess water that's not being used by the hydration process actually escapes. So it goes to, like, flows to the top of your concrete. And I like to make you picture it as like little snail trails that these little water bubbles form as they move to the surface of the concrete to form what we know as bleed water that lies on top of your concrete. And those little snail trails, or more technically known as capillary tracks, stay in place when your concrete hardens. And that, along with the fact when concrete dries, microcracks form, that both of those form pathways through your hardened concrete. And because it forms pathways through your hardened concrete, it allows water to seep through, let's say, a slab into your habitable spaces or through your walls. And it also causes an egress of salts out of your concrete. And the most well-known one is efflorescence. So if you've ever seen like a white residue on your concrete, that's salts that's being leached out of your concrete, which is not good for reinforced concrete. So that's concrete composition in a nutshell. Now, if you had to look at concrete under a microscope or even under a magnifying glass, you'll very clearly see that there's a lot of voids, and I'm sure you can see my cursor. There's a lot of voids, and these little bubbles are connected, and when they're connected, those are the capillary tracks. You've got your micro cracks, and then you can obviously see your cement paste and your aggregates. But it's very clear, although we see concrete as this, solid material, it is actually a very porous and permeable substance by nature. Now, I'm going to be using the terms porosity and permeability quite a bit during the presentation, so I thought I'd just explain the difference between the two and show you how they linked. So porosity is the number of voids inside of your concrete measured as a percentage of your concrete volume. So to make it simple, if you look at the box on the bottom left, you've got a box with a bunch of blue balls in it and a lot of white space, which is your air voids. Now, that concrete would have a high porosity because it's got a lot of air voids. If you look at the block to the right of that, it's got your blue circles as well as your little green circles, and they're all different sizes. And that could be your concrete that obviously has the aggregates and your sand particles and your cement paste. And it's filling more of the voids, it's filling more of the white space. And that shows you that your concrete or your element has a low porosity because there's less air voids. Now, permeability is linked to this, but it's a rate of flow of liquid through your concrete under a pressure gradient. So if you had water that's trying to move through your concrete and it leaks all the way through, like in the bottom right picture, it's got a pathway to go all the way through, and that's when your concrete is permeable. But if it's stopped by the cement paste and other elements, then it will be impermeable because the water cannot run through. So naturally, the more porous your concrete is, the more permeable it is. So hopefully that makes a little bit more sense. Now, concrete deteriorates. It doesn't last forever, and these are the four main reasons for concrete deterioration. Firstly, you have corrosion of your embedded reinforcing. You've got freeze-thaw cycle damage, ASR or AAR, which is due to your reactive aggregates. And then your more obvious one is damage due to chemical attack. Now, I'm going to go through each one of these in a little bit of detail because I truly believe that if you understand the deterioration processes and you understand the problems that we have, then we can start looking for solutions. Now, corrosion of your embedded steel, what happens is concrete in itself is very strong in compression, but it's weak in tension. And that's why us as engineers, we add reinforcing steel to our concrete to be able to withstand those tension forces. Now, concrete is porous and permeable by nature, so it allows water, chlorides, carbon dioxide, and various other salts and elements into your concrete. And when that happens, the pH level of your concrete drops. So it starts at around 12, 13 when it's poured, and then as it ages and these elements get in, it lowers to about, and as it lowers and it gets to about 9, 9.5, then that passive protective layer around your reinforcing gets eaten away, and that's when your reinforcing starts to rust. Now, rust is a very expansive process. It can expand up to 8 times its size, and then it forms internal pressures inside of your concrete, causing your concrete to crack and spoil. And if your concrete is not maintained, you could have eventual structural damage, as we saw in the Champagne Towers in South Florida a few years ago. So a very serious deterioration factor. The next deterioration factor is due to freeze-thaw cycles. Now, concrete is porous and permeable by nature, and when it rains or when it snows and the snow melts, water goes into the concrete and it sits in these pores and cracks. Now, whenever it freezes again, that water that's trapped inside of your concrete expands by up to 10%. And that expansive pressure causes your concrete to crack and spall. And with repeated cracking and spalling cycles, pieces of the concrete actually get like they break off, as you can see in the top right picture over there of the stairs. Pieces of the concrete have actually broken off. So freeze-thaw cycle damage happens much faster than you originally think. A 1 millimeter size crack can double in size in as little as 8 freeze-thaw cycles. So just to give you an idea of how quickly that damage can take place. The third deterioration factor is due to alkali aggregate reactions. So you get your ASR or your ACR, which is your alkali silica reactions. And this takes place in certain areas where you have reactive aggregates. Now, the reactive aggregates, when it's added to the concrete mix, reacts with the cement paste and it forms a microscopic gel layer around the aggregate. Now, that gel layer is not bad, but as soon as water hits that gel layer, it expands, causing internal pressures inside of your concrete. And once again, we end up with cracking and spalling. The last deterioration factor is due to chemical attack. Now, this could be sulfates in your groundwater. It could be sulfates in the ocean if there's piers, sulfates in wastewater treatment facilities. It could be acid spills on, let's say, a factory floor or on a gas station slab. And it can also be due to your de-icing salts. All of this eats away the cement paste and leaves your aggregates exposed because these chemicals get into your concrete deeper and deeper because your concrete is porous and permeable by nature. And Fulgens, that brings me to my first poll question, that is, what do all of these deterioration factors have in common? Is it A, permeable concrete? Oh, sorry, A, impermeable concrete, B, water entering permeable concrete, or C, pre-stressed concrete?
You have about 40 seconds to answer that. And if you have any questions, once again, please use the Q&A panel and please make sure that you're not posting as anonymous. Thank you in advance. Okay, thank you for your participation. We could go ahead and close the poll now. And Cassandra, we have 8% impermeable concrete and 92% water entering permeable concrete.
This is great, Fulgens. I'm so glad that everyone understands that, yes, the answer is all these deterioration factors have something in common, and it's the fact that water enters permeable concrete. So with that understanding, water brings in those harmful elements, right? Those sulfates, those minerals, those chlorides, and we want to stop that from taking place in the first place. And how do we do that? We can do that by lowering the permeability of our concrete or stopping water from getting into our concrete in the first place. So if we want to increase the durability of our concrete, we need to decrease the permeability. And the solutions that are available out there, there's two different kinds. So the first one is your traditional surface applied waterproofing systems. And that's when you have an actual, like a barrier, a physical barrier that is applied onto your concrete that stops the water from getting in. And then you get your crystalline waterproofing technology that makes your concrete itself the actual waterproofing barrier. Now, traditional surface applied waterproofing systems is applied to the concrete after the fact, right? Or it's applied underneath a slab, for instance, before they pour the concrete. So it's on the water, it's installed on the water side or on the wet side of your concrete. And because it's installed after the fact, it requires labor to be installed because it's either spray applied or hot applied, liquid applied, or your peel and stick membranes. And all of these methods require qualified installers to install it properly, to join it wherever there are joins. And during this process, it's human error. Things can go wrong and it can be easily damaged even when it is in place, because once you've applied it, let's say you backfill or you placing your reinforcing in place, then you could puncture it or tear it, and then um, you'd have to replace it or mend it. And it is also very, very dependable on good surface preparation. If your surface preparation is not done correctly, then it's also not going to adhere to your concrete. And because it is applied after the fact, it is weather dependent. So if you got very snowy conditions or rainy conditions, these membranes or surface applied waterproofing systems cannot be applied to the concrete. And that brings us into, you could have possible delays within your project. Now, once it is installed, it does have a lifespan, so you would need to maintain it, and then overall, in the end, you would need to replace it at its end of its lifespan. And when you're looking at crystalline waterproofing, which is the other solution, the concrete itself becomes the waterproofing barrier. And because the concrete itself becomes the waterproofing barrier, it is not susceptible to damage or weather delays. So now when you place your concrete, your waterproofing is placed at the same time. So you're saving, time, and you don't have extra labor, and you don't need to worry about weather delays. And because it stays active for the lifespan of the concrete, there is no maintenance or replacement costs that's required. So overall, it's a very cost-effective way of decreasing your concrete's permeability and then providing you with an increased durability. And it also has a benefit of self-healing cracks throughout the service life of the concrete, which I'll show you a time-lapse video of a crack self-healing a little bit later on. So looking at the benefits between the crystalline technology and the traditional surface applied systems, you'll see a reduced construction schedule because you no longer need to apply something on it after the fact. It simplifies your construction process, and with that, it also increases the amount of safety. And then it reduces the risks because you no longer have any seams that you need to worry about. It's all poured within the concrete, and then overall it is a value engineering solution. So you're getting the same, if not better benefits, but at a more economical cost because we're removing the labor component. So now that you know the difference between the two solutions, the rest of the presentation, I'm just going to concentrate on what crystalline waterproofing is. Now, it is a cementitious product that you add to the concrete either at the batch plant, or you can apply it to the concrete as a treatment after the fact, and I'll get into that in a few slides. And whether it's added as an admixture or a treatment after the fact, it contains active ingredients that needs to be activated by water. So once your concrete is in place, you cure it with water, or if it's rained on or your tanks are filled, that water form or kicks off the active ingredients, and then it forms insoluble crystals inside all of your little pores, cracks, and capillaries up to a 0.5 millimeter in size. Now, if you battle to visualize a 0.5 millimeter, if you take an average business card thickness, that is about a 0.5 millimeter in size, and those crystals will self-heal and seal those cracks and pores and capillaries, and that decreases the permeability of your concrete, making your concrete waterproof and more durable. Now, I'm a picture person, a visual person, so this is a video, a 3D animation to give you a better idea of what's happening inside of your concrete. So when you have concrete, it's porous and permeable by nature. So whenever it's exposed to moisture and liquids, the water will naturally go into the concrete. But when your concrete is treated with the crystalline technology, as that water goes into your concrete, it actually activates the crystal growth process. Now, these cracks, pores, and capillaries within your concrete matrix typically has a size of about 0.1 to 0.5 millimeters. And 0.5 millimeters is about a 51st of an inch. And as the water moves through these cracks and pores, it forms these insoluble crystals that self-heal the cracks and the pores that stops the water or any liquids from moving through your concrete. Now, the crystals have a needle-like shape and they knit together to form like a lattice that then self-heals and stops water even against high hydrostatic pressures. Now, water is necessary to activate the crystal growth, but it also reacts with calcium hydroxide and aluminum and various other salts in your concrete. Now, although it stops liquids from moving past, you can see that there's like vapor that still moves through, allowing your concrete to breathe. So it is not seen as a vapor reducing admixture. So it only stops liquids from moving through. So that's a very important point that I'd like to highlight is the fact that it stops liquids but not vapor, so not suited for vapor mitigation solutions. Then you saw a second crack form there, and that's just to highlight the fact that whether a crack forms in your concrete a day, a week, a year, 20 years down the line, all that crack requires is water to flow through it. And then over time, those crystals will grow and self-heal that crack even against high hydrostatic pressures. And then that brings me to my second poll question, Fulgens. Does the self-healing crystal formation process ever stop? Is it yes, no, or stays dormant when dry and reactivates when exposed to water?
And while they're working on that poll, we have a question from Adam. Adam asks, can crystalline be applied from inside face of foundation wall to avoid excavation?
Yes, very good question. I'm going to say yes, and then I'm going to get back to how it works because I've actually got a slide that covers that. But the post-application treatment of the crystalline, you can apply to the negative side.
Excellent, thank you. And just a few more seconds before we close out this poll. Thank you for your participation, everyone. We have 64% stays dormant when dry and reactivates when exposed to water.
Thank you, Fulgens. Well, that's a good indication that the majority of you understand that it technically doesn't ever stop, right? So the people that answered no is correct as well. It just stays dormant when dry and then it reactivates again when it's exposed to water. So that was a little bit of a tricky one, but the majority of you got it right. So now that you know how the crystalline technology works, let's take a look at a few of the benefits. Now, the most important one is the fact that it decreases the permeability of your concrete. And it's due to the decreased permeability that you have all the other benefits that's listed on the screen. So you'll see a slight increase in your compressive strength if you're using the admixture, and an increased sulfate resistance, self-healing ability of the cracks, increased chemical resistance against chemicals with a pH range between 3 and 11. And then you'll see a slight decrease drying shrinkage, freeze-thaw cycle resistance, and then very importantly, a decreased chloride diffusion, which just means corrosion mitigation. And all of these things result in a decreased amount of maintenance and an increase in your overall concrete lifespan. Now, we don't have time for all of this today, but I am going to go over the ones that are highlighted or bolded. And the first one is the decreased permeability, right? Now, to be able to test whether crystalline waterproofing decreases the permeability, there are a few test standards out there. The first one is the Army Corps of Engineers test, CRDC 48. We get the ASTM D5084. And then also the German equivalent, which is the DIN 1048 test, is the one that I'm showing on the screen today because it's the most visual. The apparatus that they put the concrete samples in is shown on the bottom right. So you've got control samples that are not treated and then samples that are treated with the crystalline technology. And these cylinders and cubes are then put in the apparatus, and the water pressure of 72.5 psi is then exerted from the bottom for 72 hours. After the 72 hours, these concrete samples are removed from the apparatus and they actually split in half, and the actual water penetration is measured. So with a control sample, you could clearly see the water penetrated 53 millimeters into the sample, which is about just over 2 inches. And then the treated sample only had a 3 millimeter water penetration, which is about 1/8 of an inch, showing that the crystalline waterproofing technology decreases the permeability of your concrete by up to 98%. This is a very similar test, just at a higher water pressure of 101 psi. So this is exactly this. This is the same concrete sample that's treated with the crystalline waterproofing additive. And for 4 weeks, it's got the continuous pressure from the bottom. And after 1 week, you can see the water penetration's about halfway. And then every week after that, you'll see less and less water penetration until at 4 weeks, there's no more water penetration that's shown, even though there's still water pressure being applied from the bottom of the sample. Now, there's two things that I'd like to highlight with this is that the crystals take time to grow and it requires water to grow. But these crystals do grow even against high hydrostatic pressures. So it's not a quick fix, but once the crystals have grown, it is a permanent solution. So very important to understand and have a level of expectation that once you pour your concrete with a crystalline waterproofing additive in it, your concrete is not going to be waterproof from day one. You first need to expose it to water to activate the crystal growth, to decrease the permeability of your concrete to make it waterproof. Now, when you use the crystalline technology as an admixture, this is not applicable to all manufacturers out there. So please make sure that the manufacturer that you're using, you are happy with their results. But technically or typically, you would see a slight increase in your compressive strength of your concrete when you use the crystalline waterproofing technology because it makes your concrete more dense. So I would not recommend you changing the mix design at all. Just use your mix design as normal and add the admixture to your concrete, and then you'll just see a slight increase. I typically see 7 to 10% is probably the most common that I see. Then this is my favorite slide. It's a busy slide, but what this is showing is there's 2 concrete samples. Both are treated with a crystalline waterproofing additive. The one sample is got a crack with a width of 0.4 millimeters. That's a 64th of an inch. That's represented by your orange line. And then the other sample, also treated with a crystalline waterproofing additive, is cracked to 0.5 millimeters, which is a 51st of an inch. Remember the business card thickness. And both of these samples have water flowing through them and through the crack. And you can see that flow rate on the y-axis in liters per hour. and how it decreases exponentially over time up to about 2 weeks, where you see no more water flowing through that crack, and that crack has self-healed. So very powerful information here. The crystals you've seen now in a 3D animation, but what would they really look like under a microscope? The top three images is a control sample. You can't really see any needle-like crystal growth. You just see the cement paste, some sand particles, aggregate. But in your bottom three images, you can very clearly see the crystal growth. They're white, needle-like of nature, and they knit together. And then they self-heal, like this is a pore, and then this is a crack that's in the process of being self-healed from both sides, and then they'll knit together and meet in the middle. Now, this is the very powerful time-lapse video that I mentioned a little bit earlier of a crack that is self-healing. So this concrete contains the crystalline waterproofing additive in it. It's cracked and water is running through this crack. And those are the crystals under a microscope. But if you keep your eye on the actual crack, the more white that you see in the crack, the more the crystals are growing, right? And the more crystal growth, the more sealing, the less leaking. So over time, and in this particular case, it was 4 days, this crack totally self-healed itself without us having to do any repairs. Now, I would like to highlight that the self-healing process is temperature dependent, just like the hydration of cement is. So the colder it is, the longer it will take. The warmer it is, the faster it will take. So this 4 days is typically fast, but I would say between 7 to 10 days is what I would normally see in summer conditions, but it could take 3 to 4 weeks in winter conditions for the self-healing process to take place. So it is temperature dependent. Now, we cannot stop concrete from cracking. I understand that. We can limit the crack sizes by doing good crack control design, following ACI design standards, but concrete cracks. And we don't always know when concrete cracks, so we can't go and repair every single crack that takes place. And if we don't repair these cracks, you would need to maintain them, right? So now you don't need to worry. All cracks up to 0.5 millimeter in size, so that's 0.5 millimeters, will be totally self-healed. And that's my final poll question is, what is the maximum crack width the crystalline technology can self-heal? Is it 0.5 millimeters, which is a 51st of an inch, or is it 0.4 millimeters, a 64th of an inch, or is it 1 millimeter, a 25th of an inch?
Thank you, Cassandra. And while they're answering that, we have a few questions here. Danny asks, does the sun affect the appearance of the additive?
Does the sun affect the appearance of the additive? Okay, I can interpret that in a few ways, depending on if you actually know the Penetron product. So firstly, the sun will not, I'm going to say, be bad for the crystal growth if you're talking about UV exposure, because I know some membranes and some liners degrade with UV exposure. So if that's the thought process that you have, the crystals cannot be broken down by UV exposure at all. Obviously, if there's sun, I'm hoping that it's a little bit warmer. So the warmer it is, the faster the crystal growth will take place. And then in the Penetron slides in the end, I will, if you're referring to the tracing agent that's in the Penetron admix, that breaks down the color of the tracing agent, but I'll get to that one.
Thank you. And let's go ahead and share the results. We have 56% for 0.5 millimeter, 15% for 0.4, and 29% for 1 millimeter.
Thank you, Fulton. So the answer there is the maximum crack width the crystalline technology can self-heal is 0.5 millimeters. So that typical business card thickness. So because cracks will self-heal when exposed to water, even when we don't know that they're there. It reduces the amount of maintenance that's required in your structure, because not only are you repairing the cracks, you are now stopping water and other harmful elements from getting into your concrete, to your reinforcing, and having that then corrode, and then we get back to the corrosion deterioration factor. So you'll definitely have a reduced amount of maintenance due to the decreased permeability and self-healing. Now, please remember the first little circle here, it says concrete with crystalline technology. You'll see there's concrete being poured and there's a green liquid on top of that. Keep that in mind. I'm going to get to that in a few slides. Now, my last technical slide is to show you how the crystalline waterproofing technology increases the service life of your concrete. Now, control sample and crystalline waterproofing additive samples were taken and placed in a highly chloride environment, so marine environment, and they measured how fast those chloride particles would get into the concrete to the reinforcing, and then the reinforcing would start to rust, right? Being the end of the service life of the concrete. Now, those chloride particles took about 38, 39 years to get to the reinforcing steel and for it to start to rust for the control sample, versus the crystalline technology samples, you between 94 and 95 years for those same chloride particles to get to the reinforcing, because the concrete is so much less permeable and the chlorides don't move as fast through your concrete. And that shows that you have a service life that's increased by over 55 years. So you're more than doubling the service life of your concrete by treating it with the crystalline technology. So we know how it works. We have taken a look at the benefits. Now, what application forms do we have? Now, for new structures, you've got admixtures and you've got dry shake powders. And then for repair applications, to get to one of the questions that were asked, you get the topical slurry that can be applied from the positive or the negative side. You have your repair mortars for bigger cracks and for honeycomb, and then your rapid setting mortars for active leaks. Now, for a new structure, it would be the most economical solution to add the crystalline waterproofing as an admixture to the concrete at the batch plant. So when your concrete arrives on site, it already contains the crystalline waterproofing admixture in it. You place your concrete as normal, and then during the water curing process, that is when the crystal growth will start to activate and decrease the permeability of your concrete, self-healing all cracks, pores, and capillaries up to a 0.5 millimeter in size. Now, the admixture does not change the adhesion properties of your concrete. So if you do want to apply any architectural finish or paint or anything over it, or even a membrane if you're doing belt and suspenders applications, then you don't need to worry about adhesion. If you're looking at it from a repair point of view, so you've got an existing structure. Now let's take the example of the question that I was asked. You've got a basement, you've got a concrete wall, it's leaking. Traditionally, you'd have to remove the backfill, replace the membrane, replace the backfill, and then it would be repaired. Now you leave everything in place and you prep your concrete from the inside. So you'd have to remove the paint if there's paint, and then pressure wash it or surface grind it to open up the capillary system of your concrete. And then you would apply the crystalline waterproofing treatment on the inside. So it's a cementitious product. You mix it with water and you either paint or spray apply it on. And once you've applied it and it's dried, the most important thing is that you have to cure it with water for a minimum of 5 days. Now, during the water curing process, the crystals grow into your concrete. And it typically grows about a foot every 50 days. So those crystals penetrate into your concrete, self-healing the cracks, pores, and capillaries up to a 0.5 millimeter in size, making your concrete waterproof. This can This crystal growth can take place even if the water is leaking from the other side, so even against hydrostatic pressures. So the topical slurry works exactly the same as the admixture. It's just applied after the fact. So you do have your labor component there, and it is longer curing times to get those active ingredients into your concrete. Now, because it is like a slurry or a treatment, you cannot put any coatings over it. If you do want to paint it or coat it after the fact, then you would have to prolong the curing process to 14 days minimum. And then once you've cured it for 14 days with water, then you can mechanically remove the topical slurry that you've applied, which sounds very weird. You've applied something, right? Now you're removing it. It's because it's a treatment, it's not a coating. And during those 14 days, enough active ingredient would have penetrated into your concrete for your concrete to then self-heal for the rest of the service life of the concrete. So very important, if you do want to coat it, cure it for 14 days, mechanically remove the coating or the treatment, and then you can neutralize the surface and then follow the manufacturer's recommendations for whatever architectural finish you want to put on after the fact. So hopefully I answered the question that was asked earlier. So it can be applied from the positive or the negative side. Now, what happens when you've got a crack bigger than 0.5 millimeters? What happens if you've got construction joints, tie holes that you need to fill, or honeycomb or spalled concrete that you want to repair? There is a repair mortar that contains the crystalline waterproofing additive in it, and those repairs can also be done from the positive or the negative side, so top or bottom of your slab, backfill side or the dry side of your structure. Or if you've got a tank, you can do, or water containment structure, you can do all your repairs from the outside while it is still full. If you've got any active leaks, so water pouring out, not just seeping through, there's a rapid setting mortar that contains the crystalline waterproofing technology in it as well that stops active leaks within 60 seconds. And I can follow up with a very cool video to show you how that works. Now, where would you use the crystalline technology? Now, I would say in any concrete that needs to be waterproof and durable, but that concrete needs to be structural concrete that does not experience a lot of dynamic forces. So any water containment structures, so wastewater treatment plants, water treatment facilities, aquariums, pools, reservoirs, water towers, those are all very good applications. If we start looking at buildings, any foundations, pile caps, elevator pits, hydrostatic slabs, retaining walls, obviously, and then cast in place parking structures. If it's the slabs, we prefer to be put into post-tension parking decks to limit those crack widths to the 0.5 and to limit those dynamic forces when the cars drive over it. Something that I would like to mention is that the crystalline technology should not be used in what they call like your Lego type or your composite slab. So slab on metal deck, when you have your precast elements with your little concrete topping on top of that, those two would not be good applications for the crystalline technology because there's too much movement and the crystals will form, but they would repeatedly break and have to reform again. So not ideal conditions for the user. Another thing that I would rather stay away from is roof slabs. Roof slabs experience a lot of thermal contraction and expansion cracking, and that's repeated. So I would not suggest using the crystalline technology as the sole waterproofing solution for roof slabs. But other than those three applications that I would rather stay away, any other structural concrete I would think would be a good application. Some examples. This is Brickell City Center in Miami, Florida. The elevator pits, hydrostatic slab, pile caps, and retaining walls are all done with the crystalline waterproofing additive. Originally, there was a membrane system specified for this project, but you can very clearly see there's a lot of water, groundwater that's seeping through, making it near impossible to install the membrane systems. And that's why they switched to the crystalline. Another good application for the crystalline waterproofing additive would be shotcrete applications. So this is Park Avenue Tunnel. They had to do a new structural lining of the tunnel, and it was about 9 to 12 inches of concrete that was shot with the crystalline waterproofing additive to the top half over the new reinforcing that they installed. So they not only incorporated crystalline technology for waterproofing reasons, but mainly for corrosion mitigation. So shotcrete is a very good application, but I would stay away from gunite because gunite, the concrete mixes at the nozzle and there's not enough mixing time. So shotcrete, yes, gunite, not so much. In any precast structures, instead of having to line or coat them on the inside or the outside, you can now put the admixture in the concrete, and then the concrete itself will be waterproof. And the only thing that you need to then take note of is the joints. Any marine application is a very, very good idea to incorporate the crystalline technology because you are providing the structure with sulfate and chloride protection. Make sure that those structures last longer and they don't have your corrosion of your embedded steel prematurely. And then lastly, the wastewater treatment plants and water treatment plant facilities. They are all very good applications, not only from a waterproofing point of view, but from a durability point of view. So chloride protection as well as sulfate protection. And we need these structures to last as long as possible. So that we don't have interruptions and costly replacements of these facilities. So in summary, concrete is porous and permeable by nature. And without us intentionally designing to mitigate the deterioration factors like water intrusion, that then causes the corrosion and cracking, freeze thaw, chemical reactions, we will have concrete that does not last as long. We'll have to maintain it. So if you add the crystalline technology to your concrete, be it as an admixture during construction phase or after the fact as a repair, it will decrease the permeability of your concrete and then give you an increased durability, reduce the amount of maintenance that's required for those structures, and overall increase the concrete's lifespan. Something that I'd also like to mention is the fact that concrete that has any liners, coatings, membranes on it cannot be recycled. Where concrete with a crystalline technology, it can be recycled. So that also decreases your carbon footprint. Your structures last longer. You don't need to maintain it as often. And the crystalline technology has a much smaller initial carbon footprint of the actual material compared to your traditional membrane systems. If you're interested in any of that, please feel free to reach out and I can share that information with you. So remember, the crystalline waterproofing, it has a complete system, admixtures as well as repairs, and it will provide you with waterproof and durable concrete. Now that concludes the AIA portion of the presentation. I think I've got 3 or 4 slides just to introduce the Penetron product range to you. The Penetron system has our most well-known product called Penetron Admix SB, which is our crystalline waterproofing admixture that gets added to the concrete at the batch plant. We try and make it as easy as possible. You can see these little bags. It's not a loose cementitious powder. We have pre-packaged it in soluble bags. So you just put 1 bag per cubic yard, very easy for the guys to add it to the truck, as you can see over there. And then when your concrete arrives on site, it is already treated. Now, we know that all of the concrete is not poured in one go. So you do have construction joints and you do have penetrations going through your slabs and through your walls. So there are solutions for that within our system. Our water stops are called Penabar SW, which is our swallowable water stop that can be installed along all of your non-movement construction joints and around your penetrations. And how it works is when water tries to move through, it swells and it forms like a high pressure O-ring inside of your concrete. Then the Panabar NS is your non-swallowable water stop. Now those can be used in between your precast structures, so your pipes, your manholes, those precast units, as they get together, you put the Panabar NS in between that to seal those joints. And then if you've got existing structures that need to be repaired, Penetron, that would be the crystalline waterproofing treatment or slurry that's applied from the positive or the negative side. So the Penetron and the Penetron Admix SB, those two do exactly the same thing. The one's just an admix and the other one is a treatment. And then if you've got your cracks bigger than 0.5 millimeter, you would then use the Penacrete mortar, which is your crystalline repair mortar. And then any active leaks, you would plug those leaks with a product called Penaplug to stop those leaks without having to drain or backfill your structures. Now, I told you to remember that little circle with the green liquid. Now, Penetron Admix, our crystalline waterproofing admixture, is the only admixture in the world that contains a tracing agent. That was added for visual quality control on the job site. As the contractor said, I order concrete with Penetron Admix in it, but except for the batch ticket, how do I know when it's placed, that it's in there? Because it's cementitious, right? It doesn't change anything. And you can now see the bleed water that comes to the surface of the concrete or bleed water that would leak out of the bottom of your forms for walls would be a luminous green. And don't worry, architects online, it does not stain your concrete. The color actually dissipates as the bleed water evaporates. And although it is quite a bright color, some people have even said that it looks like brake fluid or antifreeze, sorry. It is non-toxic. So it is a non-staining, non-toxic green tracing agent. And it's also NSF 61 approved, the Penetron Admix as well as the Penetron. So our products can be used in potable water systems. It is safe for the environment. But if you see green bleed water, you know that Penetron Admix was added to the concrete. Then we at Penetron pride ourselves in our technical support services. So we urge you to make use of these services. Our support that we provide is complimentary. So whenever you're thinking of using us, feel free to reach out to me and we can mark up your drawings, send you a full recommendation with typical details, any testing or certification that you need. And then once your project goes to construction phase, we've got account managers, local, all over the world, really. And we provide you with that on-site support or batch plant support that's needed to make sure that your project runs smoothly. So please make use of it. We love being part of a project from design phase straight through to construction phase and completion. To make it easy to specify our product range, we are listed on BSD SpecLink or SpecLink Cloud. And then the master spec, we're also listed, I know they're called Deltec Spec Point, and I think BSD is also known as RIB. And this week, and I haven't updated the slide yet, but this week, very excitedly, we have just launched on AceLab. So feel free to check us out on there as well. But if you don't use any of these specification platforms, you can reach out to me and we can help you. We've got a specification development manager, Blair Jones, that I can put you into touch with, and we've got template specification language that we can share with you. So feel free to reach out to us. We will gladly assist you. And then with that, I'd like to thank everybody for their time and then open up the floor to questions if we do have time. Fulgens.
Thank you so much, Cassandra. We do have some time for a few questions. Before that, some of you submitted your questions as anonymous. We ask that you do not submit questions as anonymous. So I sent a message to you directly. For those of you who did, please repost your question as not anonymous so it can be included in the Q&A report in case we're not able to get to it live. The first question comes from Danny. Danny says, for slabs, does the additive affect the process of acid staining colors as in floors?
Very good question. It does not affect it, short answer. So I would just advise that the concrete is cured with water for at least 7 days so that we can just activate that crystal process before you go and put an acid on top of it. And the reason for that is not necessarily for the acid staining. That's always going to happen, right? But we want to protect the concrete matrix. So we want to make that concrete as impermeable as possible and stop that acid from getting deeper into our concrete to not reach our reinforcing. So it will not affect your acid staining process at all. I would just recommend curing prior.
Thank you. Danny also asks, do the crystals grow, then shrink when dry, then grow again when wet?
Okay. So they do not shrink, they grow and then they stay in place. The only thing that can compromise the crystals would be movement. So if you've got a slab that is experiencing a lot of flexure or a lot of dynamic movement, those crystals are brittle. So they will break and then it would need water again to reform, but they do not shrink.
Robert asks, why don't the crystals grow as the water evacuates? Does it need to be continuously wet to form crystals?
So the crystals would even form in a high humid area. So even as vapor will move through your concrete, it will also form crystals, but at a much slower rate. So it will just be much slower than if actual water is being applied to the concrete or running through the crack. So it's just the time frame that's going to be longer if it's not water.
Cindy asks, after you pour a foundation and after it has cured, should you hose it down before backfilling to get the afterproofing going?
That would always be a good idea. I always say the more water, the better with your traditional surface applied systems. Everyone's hoping that it doesn't rain. I always hope that it rains. So the more water, the better. And I know during the backfilling process, they also add water in those layers as they're compacting, and that's perfect. The more water, the better. But if it's not done, not the end of the world. Whenever it rains, that backfill will be saturated and the concrete will be exposed to water.
Excellent. John asks, after crystals have formed and sealed a crack, are they finished working or will they continue to grow if an adjacent crack or cross crack forms?
Very good question. Something that's certain is concrete carries on cracking forever, right? So the crystals will carry on growing for the surface life of the concrete. So as long as your concrete is still structurally sound, whenever a crack forms, as long as it is hairline and there is water present, those crystals will continue to grow and self-heal those cracks. It's what makes the technology so unique compared to, let's say, your silane sealers, for instance. They all seal little cracks, but it's only during application. And then after that, there's no more sealing. The crystalline technology self-heals for the surface life of the concrete as long as there is water present.
Thank you. Costa asks, is a crystalline waterproofing applied only to concrete?
Yes, yes, only to concrete. Two reasons. I'm assuming you may be thinking about brickwork, blockwork, CMUs. You cannot apply the crystalline waterproofing treatment to any of those because they are too porous, so the voids are too big for those crystals to self-heal. And the crystalline waterproofing technology not only needs water to activate, but it also requires calcium hydroxide. Now, calcium hydroxide is the byproduct of the cement hydration process. So concrete obviously has cement in it. Whenever cement is exposed to water, it forms calcium hydroxide. That's actually what causes your concrete to harden. And that process takes place forever. Your concrete gets stronger and stronger and stronger over years. And that calcium hydroxide is then also used by our product or by the technology, and it grows the crystals. So if you've got block work, which is made from clays or other material or stonework, there's no calcium hydroxide to react. So that's why it can only be concrete. And then the concrete CMU or block work is too porous. So that's why we're keeping it to poured in place reinforced concrete.
Thank you so much, Cassandra. We have a few more questions, but you receive them offline for the Q&A report. Excellent presentation as always.
Thank you so much, Fulgence. Thanks, everybody. Enjoy the rest of your day. Bye.
You too. Thank you. Everyone, thank you again to Cassandra from Penotron. Another excellent presentation as always. Here is the session code 137124. It is also in the chat for you as well. Please make sure if you did post something as anonymous to make sure that anonymous attendee is not checked and repost your question so we can include that in the Q&A report for Cassandra. And at this time, we're going to review the session code process. So please hang tight for that. All right. So you have two ways to access your ATS account. The first is via ATS website, which is atsseminar.com, where you registered for today's event. And the second is via the ATS mobile app. You could use that QR code on the screen to download the app. If you need to go to your account on the website, please open up a separate browser window if you're joining from Zoom as a browser from zoom.us or zoom.com. So please open up a separate browser window and go to atsseminar.com. And once there, you'll log in like you did when you registered for today's seminar. And if you'd like to enter your session code on the app, once again, please use the QR code on the screen to download the app. And to log in, you'll enter your email address and your password. And if you get to the website and it says My Account in the upper right corner in red, that means that you're already logged in. Just go ahead and click that red My Account button and that will take you to today's agenda. And on the screen, you'll see the words Enter Session Code next to each course on today's schedule. And since we finished the first course, Benefits of Impermeable Concrete Utilizing Crystalline Technology with Cassandra, you're going to click on that dark blue Enter Session Code right there, okay? And I'll take you to this screen here. And that will take you to the session code box. In the blank entry field, you'll enter the session code 137124. And then you click on that dark blue circle that looks like a play button, and I'll take you to the course survey. And here are the very important steps to follow. The course survey is 6 multiple choice questions and 1 open-ended question for presenter feedback. You do need to provide feedback in order for your session code to process. And some of the presenters offer a sample. If the presenter offers a sample, you'll have an additional question in the course survey. And once you're done with all of that, please hit the Confirm My Presence button. And that's going to take you right back to the agenda for the day. And if everything was entered correctly, you'll see presence confirmed in a green. And that's it. And if you have any questions, please be sure to use the Q&A panel, and I'll gladly help you there. And once again, handouts from today's speakers are also available for download from your ATS account dashboard. You should see that button directly underneath the Download Handouts button. And once again, if you need any help with that, please use the Q&A panel and I'll be glad to help you there. We are moving right along with our schedule for today. At this time, I'd like to introduce you to Bo Hurley from Oldcastle. He'll present Coating of Aluminum Extrusions. Bo, hello.
Hey, how you doing today, sir?
Good. How are you? Welcome.
Welcome. Thank you. Appreciate it. Yeah, my name's Bo Hurley. I am with Catalyst Fence Solutions, which is a company of Oldcastle. I think a lot of people are familiar with Oldcastle. Um, my presentation is basically going to be on how it's made for today's PVC, and I'm looking forward to moving through the process here. So let's go ahead and share my screen. Make sure I do this right. Hopefully everyone can see that.
Yes, you are all set.
Perfect, perfect. All right, so let's get moving here. All right, so how it's made today's PVC, right? PVC is a product that's used, I mean, just about everywhere these days. So we're going to get into a great conversation. We're going to learn about how it works. I'm going to go through each slide here. Credits, just some house cleaning slides before we move forward. Copyright materials, Oldcastle and Catalyst Fence Solutions. Um, just to give you a brief thing, a lot of people don't know about Catalyst Fence. They probably heard of Barrett Outdoor Living. Catalyst Fence is a bunch of companies that were brought together by Oldcastle. So a bunch of fence companies. They pulled it together, renamed it Catalyst, and then now we were hitting the market and just kind of spreading the love of what we do, right? So our course description today, PVC products been around for 100 years. They're common in the construction industry because of their durability and long life, but old PVC manufacturing practices still cause concern for some of today's specifiers. This course will address the concerns head on. We'll talk about today's manufacturing processes and how recycling is transforming the industry. You'll see how PVC resins become a strong and beautiful product using the examples of vinyl fencing. And with the understanding of today's regulations, collaboration, and green building practices, you'll have the confidence to specify today's PVC products. So learning objectives, right? That's what we're all here for, is the learning part. Describe the elements of PVC and its history and how it's made and how it's used. Discuss today's PVC manufacturing processes that ensure worker safety, environment protection, product quality through U.S. regulations and ASTM standards. Explain the impact of recycling on the PVC industry, including the significant reduction of virgin material sourcing, toxic emissions, fossil fuel use, and landfill use. This is one of my favorite parts, actually, the recycling aspect. Understand PVC contributions to green building, including vinyl products life cycle, reduced embodied carbon, and circular economy support. Understand the contributions of PVC products to creative and durable design using the examples of vinyl fencing. All right, so part one. The PVC industry, like I was saying a second ago, it's been around for over 100 years. In fact, vinyl manufacturing and product durability have improved substantially over that time period. We're about to learn about that. So are PVC and vinyl the same? Yeah, I know people get confused by that. Sometimes people, they don't. If you talk to anyone in the business, if you mention PVC and vinyl, there is a question because they ask that. Well, hold on, is that the same product? Yes, it is. Absolutely. So when you hear PVC, you're talking about vinyl. If you hear vinyl, you're talking about PVC. All right, so the history of PVC dates back to the 1800s when two scientists, Renault and Baumann, who are both credited for the creation of PVC as a white solid with the use the vinyl chloride. I said that wrong. Not until the 1920s was it utilized to waterproof clothing and protect electrical wiring. You may have heard that PVC can be dangerous to manufacture. In 1975, OSHA first addressed issues with a standard to protect workers from vinyl chloride exposure. That stuff can kill you. It can really destroy your lungs in seconds. But we're going to talk more about that later. In the 1980s, we learned that PVC was extraordinary in plumbing and other applications because of its durability and long life. As PVC manufacturing increased, the EPA created emission standards and manufacturing regulations in 2012 to prevent toxins from emitting into the environment. And you think 2012, you're like, wow, that's been a long time. Should have thought about that earlier, but hey, we're still learning as we go along in manufacturing. Today, PVC manufacturers focus on the use of recycled PVC materials reclaimed from scrap and demolition as a primary source of new product manufacturing. So the properties, right? What is PVC, right? Well, it's 50% sea salt, 43% petroleum derivatives. PVC starts as a vinyl chloride and through polymerization form long chains called polyvinyl chloride. PVC is 50% salt and 43% petroleum derivatives. Sorry, I'm not speaking well today. I'll get it right. Why is PVC a preferred choice in many products for decades? Well, these long chains of vinyl chloride with modifiers are fire resistant with low melt temperature, chemical resistant, no VOCs, and an insulator and weather resistant as well, hence the rain jacket that you see there. Today, PVC, aka vinyl, is widely used in multiple industries. PVC used in the medical industry, like those bags that carry donated blood to the hospitals. It's also widely used in textile industry to waterproof clothing. So you see both of those right there. I can tell you also in the plumbing side, because I've been at years, all your pipe that you see is all made from PVC. So PVC is widely used in the building industry, which I just mentioned. In the construction, PVC covers electrical wiring due to its fire-resistant properties. It's commonly used in plumbing to prevent leaking, not only within a building, but also in municipal water lines. PVC is commonly described as vinyl and building materials like windows, doors, siding, decking, and fencing. Vinyl building materials are specified for their durability and extended use life. And through the extrusion process, which we're going to cover here, vinyl can be formed into uniquely designed products. You can probably look around your house and see 1,000 different things that are made with PVC and vinyl. All right, so before regulation in the 70s, the original manufacturing process of PVC used virgin material that depended on fossil fuels and could put workers to risk, right? So too many chemicals, too many virgin materials that can basically kill people in general, right? So the negative environmental impact of PVC compound development, the raw materials, feedstock for ethylene, and chemical processing. In this process, ethylene is the feedstock for PVC, a fossil fuel. Thermal cracking involves a liquid feed of saturated hydrocarbons diluted with steam and heat, and heated to extreme temperatures in the absence of oxygen. Now, PVC manufacturing regulation, this is why OSHA stepped in, right? OSHA stepped in basically to address these risks that are there. In 1975, OSHA addressed the vinyl chloride risk of manufacturing PVC and published the Vinyl Chloride Standard OSHA 1910.1017 for vinyl chloride. It states that no employee may be exposed to vinyl chloride at concentrations greater than 5 ppm, average over any period not exceeding 15 minutes. PVC manufacturing regulation, right? Over the years, the OSHA recorded injuries report, the vinyl industry resin and monomer producers producers resulted in best in class compared to overall U.S. manufacturing and overall chemical production. Also an important note, U.S. vinyl producers for OSHA recordable rates for injuries per 200,000 employees is 1/3 the rate for all chemical producers and 1/6 the rate for all manufacturing. So basically everything they put in place is saving lives, right? So we get into regulation, a little bit more on it. In April 17th, 2012, the U.S. Environmental Protection Agency promulgated national emission standards for hazardous air pollutants for vinyl chloride and copolymers production, and it developed emission limits and rules for process vents, process wastewater, stripped resin, equipment leaks, storage vessels, and heat exchange systems for major and area sources. Clean it up. That's what we have to do, right? So specify today's PVC that utilizes recycled material. So what you want to do is that anything you're putting out there, if it's recycled, use it. I will tell you, most of PVC is recycled these days, and we're going to learn more about that as well. Thanks to OSHA and EPA regulations, today's PVC manufacturing protects workers and prevents emissions of dioxide into the atmosphere, or sorry, dioxin. But using virgin materials still utilizes fossil fuels. How can we continue to use a material with so many benefits but avoid the use of fossil fuels in production? The answer is the use of recycled materials. Most of today's PVC manufacturers and fabricators are incorporating processes that use more recycled material than virgin material, thus reducing the need for fossil fuel production. So common vinyl products. As a consumer wanting to recycle, you may wonder what's considered PVC. The 3 symbol identifies the material as PVC. Municipalities are collecting consumer PVC for recycling. But PVC is heavily used in the construction industry, and that's where a lot of PVC recycling is collected, including scrap from manufacturing and reclamation from demolition. You'll see PVC is pretty much used everywhere, but the numbers are really important, especially for what's being recycled, because once it's recycled too many times, it can't be reused, right? So you have windows, all colors, fencing, pipe, and siding. I will say that in the Florida region where we're at, because we get a lot of hurricanes, we've had a lot of vinyl for recycling because people use vinyl when it gets blown out. So a lot of them are switching over in other cases, right? PVC manufacturers are working with local resources to reclaim or buy back PVC products in the construction and demolition industry. We have an overload, actually, of vinyl in Florida only because of hurricanes. So they just give it to us. So we have parking lots filled with recyclable material. In the building industry, reclaimed PVC can be ground up and processed for use in similar products. For example, for vinyl fencing, the following products are recycled: window profiles, fence, pipe, siding, and sheet PVC. Like credit card material type stuff, right? And the window profiles, any color works. We can take it all. All right, so the manufacturer using recycled material. Manufacturers and fabricators have a pivotal role in that recycling downstream of production. So we collect a lot of it, we'll grind it up, and then we start to reuse that, right? Recycling PVC does not require the use of fossil fuels or raw materials. No harmful toxins released in the manufacturing process, which is why we like to recycle more than we like to use raw material. The energy consumption, raw materials, and pollutants are no longer included in the diagram when PVC is recycled. So you can see on the right, we take everything out because now we're just focused on what's on the left. Elimination of energy requirements, raw materials, and pollutants for substrate, 85% of the product. So just keep that in mind, 85%. That's amazing considering what would happen if you had to use raw materials. All right, so quality recycled PVC goes through a sorter, and then there's a color sorter. The color sorter is pretty cool. It's all done by computer, obviously. But the other one's more of a shake method or a hand method when you do it. So when recycled PVC arrives at the facility, it's sorted based on type, cleaned, cut up, and separated by color. PVC can be reused for new products that have the same molecular structure. For example, the recycled PVC from window profiles or fencing will be used for vinyl fence manufacture because the PVC is the same molecular structure. Next slide. Okay, here we go. So here you'll see the process for reclaiming end-of-use PVC and recycling into the quality resin for new use. I'm going to go ahead and start this video. Hopefully we can all hear it.
Hello and welcome to Sita Recycling Polymers. My name is Paula and I will be your guide through the various PVC recycling processes. Firstly, the manufacturing scrap and end-of-life PVC are collected, then unloaded from the lorry. The scrap is then transferred to the shredder, ground and micronized. Using an eddy current and a magnet, the sorter separates the ferrous, aluminium and PVC materials. As a safety measure, a final metal detection is carried out before the PVC is sent to the grinder. The ground PVC, known as semi-finished, is loaded into a silo for homogenization before transfer to the micronization unit. In this unit, the PVC is transformed into various ranges of powders, which can be used directly by our customers. The micronized PVC is stored in bulk bags or silos and can then be loaded into a tanker. CETA Recycling Polymers provides its customers, mainly joiners, with large racks where they can collect their PVC scrap. This PVC scrap is then sorted manually in order to separate colors and foreign bodies, such as wood, before being sent to the grinder. Once the grinding process is finished, there are still substances which must be removed, such as seals and glue. There are two ways of sorting through the material. The first solution is to place the substance on a vibrating conveyor belt, which enables the seals to rise and the PVC to descend. This is known as densimetric table. The second solution is to separate the seals using an electric field in large rooms. This is known as electrostatic sorting. The same results are achieved in both cases. The ground and sorted PVC, known as semi-finished, is sent to storage and homogenization silos before being extruded in these machines. The semi-finished product is melted, then passed through a filter to purify it. A high-speed cutting blade attached to the filter cuts the material into granules. These granules are then cooled and stored in bulk bags before delivery to customers. You will now have grasped why sorting PVC is important. This substance can be recycled almost an infinite number of times. It would be a shame not to make the most of this.
All right. So we know through the process, right? We have all these granules, they make it happen. If you come to our facility where we do a lot of extrusion, you'll see on one side you have bags full of pellets. On the other side, you'll have crates full of material ready to be recycled. So this is our choice tool in this video. We're going to see this process again, and it will show us how recycling to quality resin for new use. All right. As you can see, there's various different ways to do this. So today's PVC manufacturing using recycled material, the target is 80% recycled materials in new PVC products. Our plan is probably to use more than that. We try to use recycled as much as possible. Um, so when we do it, we have a target of 80% recycled PVC. It goes in new fence or railing products, diverted to more PVC away from the landfills. Ironically, PVC can be recycled over and over and over again without losing integrity. That's one of the things I want to stress is that you can recycle PVC repeatedly without losing its integrity. PVC has been the least recycled plastic in the industry, but the construction industry is changing that. As you can see from the video with all the windows, as the hurricane that rolled through and blew out vinyl everywhere, we're recycling more and more every day. And that's what we want to do, right? We want to keep it out of the landfills and put it back as something beautiful. We all must be committed to recycling PVC. Transportation coordination is critical to ensure maximize efficiency and reduce energy, right? So trucks deliver and end-of-use PVC products and PVC scraps to recyclers. Trucks return the plastic resin material to the fabricator. At some point, maybe we'll find a better process so we can cut down even more on emissions. Today's PVC manufacturing requires commitment to relationships, right? So we all must be committed to recycling PVC. From municipalities to manufacturers, we all play a role. Specifiers must require manufacturer transparency. So waste collection centers, municipalities, recyclers, demolition supervisors, PVC manufacturers, and fabricators must be committed to efficiently collect and process discarded PVC. PVC is 100% recyclable. By using recycled content, a new product embodied carbon is greatly reduced. So, that's the whole input game, right? Reduce it out in the atmosphere, reduce your carbon footprint, reduce plastics floating around all over the place, especially out in the ocean these days. Specifiers also have the responsibility to require manufacturer transparency, including materials disclosures and manufacturing best practices, right? All right, so we're moving to part 2, vinyl extrusion. This is where the fun happens, right? So we recycled it, we're all ready to go. Now we're going to get through the extrusion process. Now that we know more about today's PVC, we're going to look at what else we can build with those products, right? So the extrusion process. The top diagram shows the entire extrusion process. The bottom diagram provides greater detail of the PVC resin in the hopper as it moves through the extrusion die on the far right. Okay, so the next video is actually going to show us how some of that's done. Go. There we go. righty. So that video demonstrates the feeding and mixing of the PVC resin and additives through the melting zone in preparation for extrusion. And I believe, right. So as you've seen, the second half of this process pushes the extruded PVC through a cooling bath that hardens the plastic. The form continues until it's cut into specifications. And that should be this video here.
Plastics extrusion is a continuous process in which thermoplastic feedstock material in an extruder is transformed into a molten, viscous fluid using heat and mechanical shearing. This thermoplastic fluid is then forced through a die opening where it is shaped and cooled into solid form. These forms include bar and rod, tube and pipe, or profiles such as angles and other cross-sections, flat products such as sheet and plate, flexible film for bags and packaging, monofilaments, and wiring insulation. Thermoplastic feedstock is fed to the feed barrel from the hopper. Hoppers are typically vacuum-fed automatically, but may be filled manually. As the feedstock enters the feed barrel, it is driven forward by the rotation of the screw. The feedstock plasticizes or melts as the rotating screw drags it forward. This is referred to as drag flow. Drag flow causes the thermoplastic molecules to slide over each other, creating frictional heat, which melts the material. External heating bands provide additional heat to the feed barrel, bringing the material to its final temperature. Two of the principal plastic extrusion processes are profile extrusion and blown film extrusion. Profile extrusion is a horizontal process used to make long, continuous shapes having a constant cross-section or profile. The profile is extruded into a long horizontal cooling tank or trough filled with water. This water cools and solidifies the extruded plastic as it exits the die. At the end of the cooling tank, haul-off rolls pull the profile away from the die at a uniform controlled speed. As the profile is pulled through the haul-off rolls, a cutter shears it to the required length for further processing. Some profiles are difficult to extrude because of shrinkage and the flow characteristics of the plastic. Typically, generous internal and/or external corner radii are used to minimize these concerns. Additionally, some profile extrusions may also require inline sizing to achieve dimensional tolerances. The blown film extrusion process uses an extruder to pump molten plastic vertically up through a die having a 360-degree annular opening on its top. This produces a tubular film extrusion, which is subsequently filled with air. As a result, the tube expands out into a bubble, having a diameter larger than the diameter of the annular opening of the die. The tubular bubble cools as it is pulled up. When sufficiently cooled, the bubble is flattened within a collapsing frame. The flattened plastic is then pulled through a series of rolls, commonly referred to as nip rolls. Nip rolls help to maintain tension on the flattened plastic film as it is guided to a winder and wound onto a core for later use.
All right. So let's talk about testing. ASTM provides numerous testing methods for plastic, including impact resistance, tensile properties, deflection temperature, relative density, and flexural properties. ASTM D4216 provides the standard specification for rigid poly PVC. ASTM D638 standard test methods for tensile properties of plastic. ASTM D648 standard test method for deflection temperature of plastics under flexural load and the edgewise position. ASTM D792 standard test methods for density and specific gravity, relative density of plastics by displacement. ASTM D790 standard test methods for flexural properties of unreinforced and reinforced plastics and electrical insulation materials. And ASTM D4216 standard specification for rigid polyvinyl chloride, PVC, and related PVC chlorinated poly building product compounds. It's a mouthful, but there's a lot of different specifications that are used for testing PVC and their processes. ASTM F96-13 2019 is PVC exterior fencing and railing. Basically, this profiles used for agricultural, commercial, and residential fencing and railing. It states that materials shall be tested and shall conform to requirements for the material properties and physical properties, including dimensional tolerances, extrusion quality, and weatherability. Methods for testing and for identifying exterior profile extrusions, such as impact resistance, warp, dimensional stability, and the impact test on weathered specimens that comply with this specification, are also provided in the standard. Some of those considered, when you look at it, UV fading, fire, impact, wind, freeze. We're very proud of our UV rating at Catalyst. High quality PVC resin are critical to meeting the ASTM standards for PVC exterior fencing and railing. This includes specifying the right additives and modifiers, which are added to the extrusion process to give the fence greater durability to meet those standards. Adding these additives and modifiers deliver a product that is virtually maintenance free. Shouldn't fade, shouldn't turn yellow, should look beautiful, whether it's white or multicolors. These modifiers added after polymerization provide resistance to, and this is what we just mentioned across the board here, UV fading, including UV inhibitors that prevent ultraviolet degradation and assure minimal weathering. Fire, impact, wind, and freeze. All those beautiful pictures. Vinyl fencing is manufactured to avoid abnormal peeling, rotting, blistering, rusting, flaking, and corroding. Many manufacturers implement constant monitoring and quality testing at every stage, including hourly testing to withstand extreme weather. Part 3, green building contributions. PVC, known as for its durability, this recyclability. Vinyl products also support green buildings, so keep that in mind. The more we recycle, the more we go back to the green spectrum, right? So vinyl life cycle analysis. With collaboration and coordination in all areas of the supply chain, vinyl can be produced, used, recycled, back into use over and over and over again. We spoke about that earlier. It can constantly be reused. And most of these critical elements in the vinyl life cycle is the collection of scrap, demolition material, end of use. So the bright green circle, supply collaboration, and transportation coordination is critical to efficiently collecting material to be recycled and then delivered to the PVC resin manufacturer. That's the purple circle here. Vinyl fabricators, the darker green, are just as important in collecting scrap and specifying the resin product required for the high quality vinyl products. That's where we come into play. A lot of what we get comes right to our property that's dropped off and donated, and we like to reuse it. So you may have heard of the circular economy. Oxford defines a circular economy as an economic system based on the reuse and regeneration of materials or products, especially as means of continuing production in a sustainable or environmentally friendly way. Buildings are the largest consumers of natural resources. They are the greatest contributors to greenhouse gases. Construction and demolition create huge amounts of waste. A circular building prioritizes the reuse and regeneration of materials. The recycling goals of the vinyl industry support circular building strategies and sustainable manufacturing. So we can't overlook the extended product use of vinyl product. The durable product that lasts longer extends the life cycle and reduces the need for maintenance and replacement. Embodied carbon, right? The extended use life reduces the embodied carbon of the project. Embodied carbon is the amount of energy used in the entire life cycle of a building product, including energy used in raw material extraction, transportation, manufacturing, installation, operation, end-of-life disposal, recycle. Use of recycled materials lowers the embodied carbon of new product compared to the original product that used virgin materials. Like I tell my kids, reduce, reuse, recycle. The Vinyl Sustainability Council developed an independent third-party sustainability verification program called Vantage Vinyl. This organization encourages performance improvements by companies throughout the supply chain. The 3 vinyl categories that drive improvement focus on recycling, emissions reduction, health, safety, and welfare for the workers, the community, and the product users themselves. I'm in the line here. Industry-wide accountability. When specifying vinyl products, confirm the manufacturer's member with the Vinyl Sustainability Council. So there's something out there that you're looking at that you want to specify in your project. See if they're part of this group here, because then you know that you're getting a product that's been recycled, reused, and they're focusing on being green more than anything. American-made vinyl products made in the USA. Choose PVC manufacturers and vinyl fabricators in the U.S. who meet ASTM standards, testing standards, OSHA regulations, EPA regulations, and Vinyl Sustainability Council environment and human impact expectations. All right, so we're on part 4 on today's vinyl fencing. And now that you know how vinyl's made its benefits, we're going to take a quick look of how fencing or how vinyl is used and designed with vinyl fencing. So the vinyl fence began as a split rail for horse fencing in the 80s. Today, the vinyl fence has evolved to accommodate numerous uses and designs. I learned this the other day and I didn't know, so a little tidbit is that horses like to eat wooden fence. Didn't know that until I saw a picture of an actual bite taken out of it, and that's why vinyl kind of came into play a little bit to keep the horses from eating it, I guess. You can also use a mixed use product. So you can use vinyl, you can use aluminum, you can use wood. You can mix a couple of different product lines together if you like. There's a lot of flexibility in vinyl itself or in PVC. You'll see if you go to catalystfence.com, if you go to our website, you'll see there's so many different, and I always call it flavors, PVC fencing. It's amazing that we can make as much as that we do. All kinds of different designs. Textures, smooth, or like if you look at this one here, that's like a wood texture. You can get styles that are private, basically for any kind of, privacy that you need. They come in varying heights, so you can get 6 foot, 8 foot, 4 foot. I mean, you can get just about anything. You can also do semi-private if you like. Semi-private gives you a little bit more space. It's breathability. So you can also see through it, but wind can flow through it. If you're in windy areas, you probably want something like this. The fencing here, this is where I'll go back to just Florida in general. Anything that was like this and solid in the Florida area pretty much got blown over, got destroyed. There was nothing they could do about it. I mean, when you have winds of 100 plus, you have to live through it. Shockingly, some of this stayed around, partly because the wind can fly right through it. That's just obvious, right? But amazing how this would stand up where you had that flat surface and it got crushed. And then you have vertical and horizontal. You have different ways to do your designs, right? So if you're an architect and you're designing fencing around a project, keep in mind there's so many different ways to do it. You can always find something unique and interesting that's good for your project in general. So styles. Tons of pickets out there. You can get tons of different designs, different facades that are available. If you look at this one here, they actually have like these pickets in the middle and then pickets on top. We make this product line. You can see here that you have the bow that comes in it and the different pickets that are there. So you can have it for design. They actually did like kind of a mix in here. So for this guy in the background, he wanted privacy fence. So he put in a privacy one. And then over here, this could be like maybe a playground or something. They did an open fence so that way you could see through it, but there's not as much privacy, so semi-private. Gates, all different kinds of gates you can imagine. We actually have a product, a Catalyst fence called the no sag gate. Um, Basically, if you look at the fence post, there's a piece of metal that's put inside of it, and it's designed to keep the gate from sagging. And I think most people, if you have a vinyl fence, you've probably seen it sag at some point where it's dragging on the ground. These look pretty good here, but a double fence, the latches, I'm pretty sure they have probably a stay straight or that bracket system on the inside to hold this together. That's something that's requested. It's not usually sent out, so most builders out there probably won't use it, installers, unless you ask for it. I would specify it if I was doing it and putting in a vinyl fence, simply because I know these gates will never drag on that concrete or drag in the dirt or wherever. They'll stay like they are. We did a test where we hung a 45-pound weight on the end of a gate, and we swung it about 1 million times, and it survived. The goal was to mimic a child, right? So kids on your gate swinging it, let's see what happens. And it surpassed. It did great. Railings. Once again, it's all done from perspective what you'd like to design, but it looks like a fence, but it's a railing. You can use it for many different applications. Once again, when I look at something like this, I would think I'd probably want that structural integrity on the inside. So that way these stay in place and they're not bending or flexible. I've seen designs where you walk up and you push on the railing and it kind of moves a little bit. That's what you don't want, right? Color options. So when you have PVC and you're using PVC, you can put many different colors in. Traditionally, what most people see is probably white. We use a protection system that basically keeps ours from fading. I know some of the stuff you get from other manufacturers may fade or turn yellow over time. Ours doesn't do that. It will stay white for as long as you can imagine, right? We have a lifetime warranty. So you have sand colored, clay, slate, driftwood, weathered aspen, and dark walnut. For the ones that we do with these, we actually have them textured. So you kind of feel like wood, and you can do that with PVC. It's pretty cool how that's actually handled and now it's designed. You have many, color options. I'm going to run into a couple of more options here. As you can see here, texture dark sequoia, texture tan, texture clay, texture driftwood. I will have to say, when it comes to vinyl and PVC, I was blown away that you can make it look like wood. You can make it feel like wood. And it's plastic. It's PVC. It's vinyl. It's not even the thing, and it will last up forever in a sense. Well, until a hurricane takes out, right? But it will last for just about a while. Where if you put wood in, wood rots, right? Specification guidance. When you're specifying vinyl fence, just keep in mind most panels are going to be 6 foot. Some are 8 foot. You can do it either way. We like to stack them in packaging, so that way it comes together as a whole kit. So when we have it delivered, you can easily put it together, as you can see here. And you can look in this picture, you can see how with today's manufacturing processes, I mean, this looks almost like wood. I mean, how close to wood is that, So it looks aesthetically pleasing, even to the touch. You don't have to worry about it rotting away or falling apart over time, right? Rails, tongue and groove panels. So this is your typical way when they extrude it. They're going to extrude all these different pieces and parts, right? And they extrude it in a way that it all can fit together, almost like a Lego in a sense. I mean, Legos obviously have those little pegs on top, and they squeeze it together and they form it. Panels are kind of the same way. They just don't have those pegs, right? So when you put it all together and you squeeze it, it all pulls together, and then you put it in between the posts, and that keeps that structural integrity. But this right here is what you would typically see in vinyl. So we extrude the top rails, we're going to extrude the sides, we're going to extrude all the panels, the bottom rails, and then even stiffeners on the inside. In some cases, we use metal stiffeners to stay straight. Other times, we use rigid PVC as a piece that goes inside. It probably depends on your product or what you're willing to pay for. But in a sense, these all pull together and make a great product, and it's all extruded in the same processes that everything we just watched, right? So you can see the components of the complete assembly and how all those extruded parts come together. And then you have what's one of our final products. This right here is a mixture blend of that wood that we're talking about, that textured feel. Then you have your post, and then you have your top rails and your bottom rails. To me, when I look at this, I am blown away that this is actual PVC and vinyl, right? And it's not wood. So an incredible product that's going to last for days on end. And I think this comes to the end of our products. Yes. I guess, is this when we go into questions?
Yes, we have a few questions, and anyone who's submitting questions, please submit your questions in the Q&A panel and not the webinar chat. Please submit your questions to the Q&A panel and not the webinar chat. Thank you in advance. And we also have a few poll questions we like to launch here as well. So we'll launch the polls and answer some questions at the same time.
Cool.
Here's the first poll question. Which PVC products can be recycled? Select all at apply. And while you're answering that, the first question comes from Michael Martinez. Recycling is good and all, but are there any more sustainable materials being developed that could be utilized to eventually replace PVC?
Well, so there's a lot of different products out there. I don't know about exactly when it comes to PVC, when you have so many different like pipes and things like that. I can tell you in fencing, we offer a variety of different things. So like PVC fencing, we go to aluminum. We also have a polyvinyl. Sorry, not a polyvinyl. What's the one I'm looking for? It's a what is it called? It'll come back to me in a second. But yes, you can use multiple different things. But I will say that with the future of PVC, I think PVC is going to be here to stay for a lot of the product lines that are available.
So excellent. Thank you. Let's go ahead and end the poll here, the first one. And so the majority is reporting all of the above. And let's go ahead and launch the second poll. Go ahead and establish that one. How many times can PVC be recycled? We'll give you a minute to answer that. And let's take another question. So Adam is asking, is the use of plastic restricted by building codes in regards to flammable products?
I think it depends on the product itself. But yes, I think so like for instance, when you're using PVC pipe inside of a building, I know most PVC pipe is resistance to flame to an extent. But there are plastics out there that melt really, really easily. So yes, I would say that there are building codes and requirements that are in place.
Excellent. And Sarwit asks, is the vinyl fence stronger than wooden fence?
So that's a good question. Yes and no. Yes and no. And the reason why I say that is because you can get really, really cheap fencing, right? That is you can probably put your hand through it if you hit it hard enough. Or you can get quality fencing when it comes to PVC that is solid. Like so one of the ones I was showing at the very end right there, definitely stronger than wood, hands down. But you see a lot of white fencing, like if you go to Home Depot or Lowe's and they have stuff on the shelf that you grab and pick up, you don't know where it's really coming from. I mean, it could be coming from overseas or something like that. It's not really made to the standards that somebody like us, Catalyst, would make our fencing. So yeah, your answer goes both ways. Depending on the product itself, yes or no.
Excellent. Thank you. Let's go ahead and end this poll and share the results. We have 68% repeatedly without loss of properties, and 26% 1 to 3 times. When it breaks down, it cannot be used again. 6% once only. What's the correct answer there, Bo?
You can use it repeatedly.
There you go. And a question from John, does PVC outgas?
So ask that again.
Does PVC out gas?
Out gas. What do we mean by that?
John, can you please rephrase your question? Thank you. Question from Chip. What products can be used to remove grass stains from PVC fences? Also, what products can be used to patch holes from a weed eater?
Somebody was going to bring that one up. I'm assuming that the bottom of his fence got eaten alive.
Yeah.
So one of the things in the fencing industry is that you want to keep your fence slightly above ground level so you can actually do it with a weed whacker. Honestly, I'm going to tell you, you're just going to have to replace that part of the fence that broke. There's really nothing to really patch it. Probably try to do something if you want, but reality is you probably just want to replace that panel or that piece that you broke. As far as grass stains go, man, that's a good question. I don't even know the answer to that one. I know that I've removed stains before using like a rubbing alcohol compound on plastics on PVC, so that may be something that works. You can try that, and if it does, tell Fujins, and he can tell me later, so I can use that one.
Exactly. Okay, so John is rephrasing it. Out gas, release chemical vapor or gas over time.
No, so once it's made, right? Unless you burn it. So you shouldn't have any gas issues or anything coming off of it unless it catches on fire. And I know a lot of times they say PVC can be like almost flame resistant to it, but it's still like it's still going to melt. So that's the only time you'll probably have gases from.
Excellent. Thank you. Let's go ahead and end this poll number 3, which is which properties are associated with PVC. Select all that apply. And the majority again saying all of the above. Thank you for your participation in the polls. But we do not have any more questions at this time.
Cool. So we're good to go?
We are good to go.
Thanks, everyone. If there's anything you need, just reach out to us. We'll take care of you.
Thank you so much, Bo. Appreciate it.
Thank you.
All right, everyone. Here is your session code. Also entered in the chat for you all. 137148. 137148. And I am going to go through the session code process again, just to, for those of you who are new, and because I did get a few questions during the course for the session code review process. So since we have some time before break, we'll just go over it one more time and then we'll go to break. So here we go. All right. So once again, you have 2 ways to access your ATS account. The first is via the ATS website at atsseminar.com. And the second is via the ATS mobile app using the QR code on the screen right now. So to go to your account again, please open up a separate browser window and access atsseminar.com. It's the same place where you registered for today's seminar. Okay. And again, if you would like to enter your session codes on the app, please use the QR code on the screen and download the app. And to log in, please enter your email address and your password for your ATS account. And if you get to the website and it says My Account at the top right corner, that means that you are already logged in. Just click on that red My Account button and that will take you to today's agenda. Now on this screen, you'll see the words enter session code next to each course in today's schedule. So since we've just finished the second course, and sorry again, we had a course update, so please refresh your accounts. We'll announce when that aluminum course will be available at a later date. Sorry about that. So please refresh your accounts and you should now see how it's made today's PVC on your agenda if you're already signed in, okay? And click on enter session code there, all right? And then I'll take you to the session code box. And in the blank entry field, you enter the session code 137148. The one that you're seeing on the screen now was the session code for the first course with Penetron. And the course survey is 6 multiple choice questions and 1 open-ended question for presenter feedback. That's after you submitted your session code. You'll come to this screen here. You do need to provide feedback in order for your session code to process. Some of the presenters offer samples. So if the presenter offers a sample, you'll have an additional question in the course survey. And once you're done, hit the Confirm My Presence button. And that will take you right back to the agenda for the day. And if everything was entered correctly, then you will see presence confirmed instead of enter session code. It'll switch to presence confirmed. Okay. And if you have any questions, once again, please be sure to reach out using the Q&A panel. So please direct all of your questions to the Q&A panel. And as a reminder, we will report. Where am I? We will report AIA, GBCI, and AIBC credits on your behalf within 10 business days. And if you're a member of AIA, GBCI, or AIBC, please check to make sure that your association numbers in your ATS account are accurate so we can assure a smooth crediting process. And for everything else, you will get a certificate in PDF form. That is 1 certificate for every course you take with us today. And those will be available immediately after entering your session code, okay? And where can you find those certificates? Once you log into your ATS account at atsseminar.com, you will click certificates on the left. Then you will see all the courses you've taken here at ATS. And to the very right of that, you'll see a small certificate icon. And when you click on that, your certificate will pop up. And here is what your certificate will look like. And handouts from today's speakers are available for download from your ATS account dashboard as well. All right, and with that, we are going to take our very first break, and we'll be back at 10:30 a.m. and with a word from our sponsor at Lincora. Hang tight, see you soon. Enjoy your break. Welcome back from break, everyone. We're moving along with our agenda for today. At this time, please help me welcome our sponsor, Fred with Lincora. Fred, hello, how are you?
Very good, Fulgence. How are you? Having a good morning?
Yes, sir. How about you?
Wonderful, wonderful.
Awesome.
I see you're talking about durable design solutions. I'm glad because this is what we offer. Durable lockers. Our products will last for 35, 40 years if they're well adapted to the environment and the users they are here to serve. So I'll get started, Fulgence. I'll start my little timer here.
Yes, please. Absolutely. Go ahead
I
and
try
share
as
that
always to
screen.
respect your time, so important for us. Here you go. Just let me know that we're all set. You have the full screen version.
Yes, sir. Take it away.
So there you go. We are a locker manufacturer, all welded metal locker manufacturer. And we're not lying when we say custom is our standard. We've given ourselves the tools, the technological tools, very unique tools in this industry to make it possible. We basically have the dimensional capabilities that you would have from a windows and doors manufacturer, but for lockers. So let me get started. I'll explain to you how this works. So we were founded in 75. Yep, we're celebrating our 50th anniversary this year. A few pictures of our factory here. We're located in Montreal, Canada, and have been since the beginning. What we do is what you see on the screen. Top quality, premium, standard, and custom metal lockers. We operate in these 4 sectors. Education, of course, being a pretty large sector, close to 50% of our sales. Healthcare projects, public safety. We've developed very specific projects to respond or to answer our first responders requirements, and other markets we would include in their mines, manufacturing companies, distribution, and anywhere where you would find locker rooms. This is where we also operate. So at Lincora, again, we perform well on large projects. We minimize your risk and ensure your complete satisfaction. So we are a project-based manufacturer. We hold no inventory. Every project is unique for us. How do we add value? Glad that this is today's topic. Durability is certainly something that we offer. Our products are premium. We offer this customization with this tool that we have, the unique configurator, and we have an advisory approach for every project we take on. This is where here at the sales department, we get involved in making sure that the users are well served. About durability, our belief is that to protect we protect the environment, and therefore we make durable products that can be recycled. Our products are designed to support LEED certifications. We offer the environmental product declarations. We're completely how would I say, we do have these declarations, and they are current up to 5 years. We provide all these documents that you need for your project lead, so you get your point on the lead projects that you're working on. How do we add value? Again, durable products. Our lockers are all welded, which provides better structural integrity, better abuse resistance, aesthetics, smooth finishes. So welding lockers is far different than what we see often out there on the market. Lockers that are, as you see on the screen, assembled by rivets. This is not what we do at Lincora. You can tell how the seams are great, how the components of that locker are not fused together. It makes it for a rickety locker. This is an all welded solution, a lot less pre-perforations, a lot less, of course, rivets, because we fuse steel together for a much better durable solution. A few things we do to make sure that the products are durable. We'll slope the bottoms towards the front. We'll do perforations at the front of that at that bottom, so that the water exits out at the front. The last thing we need is to have humidity under the locker. Humidity is the enemy here, so we do everything in our possible designs to eliminate the humidity inside the locker. We raise the lockers on bases, the black part here to the right. The bases are critical to improve on durability. They protect the locker off the ground. They are made of galvanneal steel, a zinc-coated protection on the steel. We powder coat everything at Lincora. The base could also be done out of stainless steel if you're expecting a lot of water. These are all things we do to avoid what you see on the screen now. Those locker bottoms rust fast. This happens fast if it's not taken care of. So we assess this during our advisory approach, which I'll be telling to you a little bit more later on. We operate with 12 standard colors, but we can provide and assist you with any special colors from the RAL, Pantone, or any other paint manufacturer's colors that reference that you would want us to work with. And designers are having fun with our lockers and the colors that we can do. Again, we powder coat everything for a far better, more resistant, durable finish over time. These are projects where you have the lockers that have incorporated benches on them. These are mining projects that we've worked on, recreation center projects. Some of the lockers here are made of stainless steel. We do offer this. Where we know that there's going to be a lot of humidity, we do protect the lockers with, again, galvanneal steel or even stainless steel. In terms of customization, a very important part of this presentation, the configurator, we have an adjustment level that goes far beyond any other locker manufacturer out there. We can adjust lockers in 1/8 of an inch increments. What you need to remember is that, again, we give you the dimensional capabilities of a windows and doors manufacturer, and our range in terms of sizes, you see them here. What we see on the left side is what we see most commonly in terms of sizes, but at Lincora, for example, the width of the locker starts at 9 inches and ends up at 45 if we want to, if we need that. And the process is the same for us, whether it's a standard size locker or whether it's a custom size locker. So this customization capability comes at absolutely no extra cost. So with the configurator, we have some benefits. Here are the 3 main benefits. We can first and foremost imagine and create the locker that's going to meet the storage needs. Finally, it's not just a standard metal box with a door on it. What we're trying to avoid is often what we see out there on the market, whether it's for schools or industrial lockers. What you see on the left is what we're trying to avoid. So easy for us to improve or increase the width, the depth, and the height, adding options, shelves, adjustable shelves, just to make the storage system this personal place at work for the employees or the users. We make it, we adapt it, and it does not come at any additional cost for you, except for the additional materials we would use in the lockers. Number 2 benefit of the configurator is that we can adapt to the space and not the other way around. So here's a typical example. There's a large locker room for a high school. They wanted to have 15-inch wide lockers, as they had a lot of other users have the capacity issue. They want to increase the capacity. In this specific case, they did not want to go down to the next size in terms of width, which is 12 inches. So we offered a 13.5-inch wide locker as opposed to a 15. And then you can see where we can increase the capacity with the same space. So we've increased the capacity by 12% here. This is the advantages of the configurator and our process. Number 3, we can adapt during the construction of the project. It often happens that the rooms are not built per plan. And we just, if we have enough time and we're advised in advance, we can adjust the locker size to fit the new room space. In terms of our process, it always starts with a survey form where we address all the needs. And this is easy. We do this for you. It could be a quick conversation over the phone. We take a careful look at what the user storage requirements are, which is something that is often forgotten. So we take a look at that. And then what we do with the survey form is we'll go into the configurator. And once we configure a locker, what we get is a drawing, just as the one you see on the screen right now. And it takes minutes for us to obtain this drawing. And the beautiful thing is once that drawing is done, I can actually create these specifications for you. No problem. You want to make this a performance spec, take our name off. We provide this for you. We save you time and we're accurate with our specs. It saves you time before and after. So we're with you every step of the way. And once we have the order, following all the tender processes, we have our equipment. We use a very specific number off of that configuration that carries all the manufacturing data. This is why the process is the same for us, whether it's custom or standard. So there's no extra cost to that. So what you need to remember, we'll help you with the product's choice. We have the tailored specifications for you. We provide all this for you, and we can even do budgetary costing on your project so that you get an order of magnitude from at the forefront. Our specifications are available on ATS, on Lincora's website. We also use RCAT. A few projects real quick, where we ventilate the locker. We make sure these are police station projects that we do pretty often here at Lincora. We do a lot across North America, and the lockers offer constant airflow through the building's mechanical ventilation systems. A few other examples of what we've done. So there you go. We offer durable product, customization at no cost, and a great process that saves you time. Contact me. Don't hesitate for your projects. I'll be glad to help you out and produce configurations for you. I believe we have a few questions, Fulgence.
Yes, we do, Fred. There was a question that came in earlier. Do you furnish any NFL football teams? And I can expand on that too, like probably stadiums and other lockers as well, like that.
I do not have any examples of specific NFL football team locker rooms right now. No, sorry. I wish I did, but no.
That was an awesome question. William asks, can you also manufacture and provide separate benches?
Yes, we do. Absolutely, we do. But please contact me, because there are better ways around this to save space in the locker room. We incorporate the benches to the lockers. Maybe you've seen some of our lockers with the drawers on them during this presentation. I know it's fast. I went through the slides pretty quickly, but please contact me. I might have some recommendations here for you. But we do make freestanding benches for the locker rooms, yes.
Awesome. I have the first poll going while we continue asking these questions. So the second question comes in from William. Do you make any, well, there's two related questions here. Do you make any lockers for the storage of explosives, weapons, and sidearms? And the second question comes in, says, can it have gun storage, and what does this entail?
So we do number one, we do not make lockers for explosives. This requires some specific steel gauges, very thick steel, and I'm not absolutely certain of what is required to call our locker or a storage compartment explosive capable. So we do not do these. However, in terms of gun storage and sidearm storage, we offer lockable compartments within the lockers. You might have seen in the slides I presented, some of the projects on there had these internal lockable compartments on top of the shelf or right under the shelf inside the locker. So we do offer that. I did have a few renderings of gun compartments on their own as well. And we are working on a range of firearm and weapon storage systems, a little bit more adapted to public safety projects and even defense. So please contact me if you need more information about that. I'll be glad to take a look at your projects and maybe bring in some solutions for you.
Perfect. Thank you. We have 29% people would like to see a demonstration of the state-of-the-art Lincora configurator. Thank you for your participation. And let's go ahead and launch the second poll there. Would you like Lincora to contact you and organize a presentation for your team? And we have another question from Adam. How do you balance the ventilation in mechanically vented individual lockers?
So what we do is we'll offer an adjustable, we perforate the locker's top. It's a 4-inch round hole, and we add an adjustable air baffle to that. And from there, it's left to the consultants to adjust that baffle based on the exact airflow that they want within the lockers. So we do not actually control this. It's up to the HVAC consultants or trade to take care of that.
Perfect. Thank you.
I hope that answers the question.
Thank you. Let's go ahead and end the poll, share the results here. We do have quite a few people who would like Lincora to contact and organize a presentation for their team. Thank you for that, everyone. And the third and final poll question here. Would you want Lincora to get in touch and assist you with current locker projects? And William asked a question in regards to what about home rifle long gun storage?
We could configure some long gun storage lockers. We again have a full dimensional capability, and we'll create any storage system based on the configurator's capabilities. You did see the range of dimensions, but I can be a lot more precise with you in a head-to-head conversation on a team and help you out with that. I have a few pictures where we've created some good systems and very reliable weapon storage systems for police stations mainly, and some defense agencies.
Excellent. Thank you so much, Fred. We do have a few folks here who would want Inquiry to get in touch and assist with current locker projects.
So I'll be sending an email to those that have responded yes to the different questions. In terms of presentations, we also do lunch and learns remotely, depending on where you are. We've done this before. We just order in some food and I present Lincora products and solutions for 60 minutes while we take care of food and beverages for you. So thanks a lot, Fulgence. I do appreciate it. And I'll be in touch with everyone that has responded yes to one of our 3 questions.
Yes, absolutely. Thank you so much, Fred, as always.
Take care. Have a great rest of your day.
You too. All right, everyone. There is a sponsor code for you as well. 137142, 137142. Please enter it along with your session code. You'll see a section in your agenda to enter the sponsor code just to confirm your participation for today's event. Thank you again. If you have any questions, please use the Q&A panel. And at this time, we're moving along with the agenda. Please help me welcome my man from AdFast, Dan Garnett, with Building Facade Glazing, Key Installation Procedures and Considerations. Dan, how are you?
I'm well. Thank you, Fulgence. How are you?
Very, very good. Good to see you here. Welcome back.
Yes, sir. Thank you. Let me go ahead and get my screen up while you're with me to make sure we're good to go.
Yes, sir.
Okay. How's it looking on your side, Fulgence?
It is looking great. You're all set. Take it away.
Okay. Thank you so much. So, hey, everyone. My name is Dan Garnett. I'm the Market Development Director for AdFast. We are a Montreal-based chemicals firm that is specializing in adhesives, sealants, and insulating foams. And today we'll be speaking to you primarily about building facade glazing applications, and we'll take a deeper dive into the installation procedures and various different types of considerations for you all to keep in mind as you're looking at your upcoming projects. So without further ado, I'll get going with the presentation. But first, I'd like to, if Fulgence, you're still with us, if you don't mind dropping in the first poll question to help give me an idea of the type of audience that we're working with today.
Absolutely. Here's the first poll question. Which type of construction projects does your firm primarily engage in? And we'll give you about a minute to answer that.
Thank you.
And while you're working on that, folks, sorry about the sponsor code typo. It's 137172. 137172. Sorry, John. Sorry, folks. I typed it again in the chat. 137172 for the sponsor code. Sorry about that. All right. Thank you for those who participated in this poll. Let's go ahead and end and share the results with you. Dan, we have 26% commercial construction, 37% residential, 11% mixed use, 18% institutional, and 8% industrial, civil, green, or other.
Great, thank you so much. And thank you all for participating in these brief polls. That one in particular is very important as it helps me to potentially cater some of the presentation content more toward some of the applications you all will be coming across for your projects. Looks like we have a pretty good mix here today. It's actually unusual. Usually we're a little bit more one-sided or the other, so that'll be great. It'll make for some great Q&A toward the end of the presentation. But of course, if you have some questions along the way, please feel free to drop it in the chat, and then Fulgens will try to interject, to get a question or two in. And if we have some time at the end, we do have a ton of material to get through, but if we have some time at the end, I'll of course be available to answer some questions there. And if we can't get to your question today, no worries, I'll get back to you right away. So just please drop it in the chat. And if you have any other items regarding a current or upcoming project that you'd like to have some consult on from an adhesive sealant perspective, feel free to reach out anytime. My contact information is there in the chat. So thank you, Fulgens, for dropping that in. Okay, let's get underway. Okay, so in today's building facade glazing presentation, we're primarily going to be taking a look at how to choose the appropriate sealants for use when designing and building curtain walls and also storefront sealant applications. It does say silicone here. We'll make a case for that over the remaining slides for the presentation for a neutral cure silicone. As a manufacturer of many different types of adhesive sealants, including polyurethanes and hybrids with some water-based, acrylic type, latex caulking, a little bit different than an adhesive sealant that would be used for movement joints. However, we'll briefly look at some of the various different sealant technologies that are utilized in commercial and residential, institutional, civil type of construction projects. And we'll make the case here that the neutral cure silicone is the one that is the technology to primarily look for your upcoming projects. We will take a look at some structural and non-structural applications. We'll do a pretty deep dive into the curtain wall systems, especially as it relates to some of the testing that goes into the ASTM testing that goes into the various different factors that you should keep in mind with regard to adhesion and compatibility, movement, capability, as well as things like preventing staining or sag and so forth within your joint cavities. We want to be able to take a look at some of the various different types of joint configurations that are fairly common for these types of projects. And we also want to highlight and emphasize the fact that it's not just about understanding the various different sealant technologies so that you can choose the best sealant for the application. It's also a matter of understanding the importance of the installation procedure and some of the things that we need to be doing prior to installation, including potentially some pull tests at the mock-up stage. Of course, reaching out to ADFAST or some of the other manufacturers such as Dow, Tremco, Sika, Pecora, some of those that are in the same space as ADFAST, to actually help in the design phase. We can assist a great deal in design phase, or at least go ahead and provide a smiley face and 100% A+ at the top of the spec if everything looks pretty good. So we need to understand that it's more about this entire system than just about the adhesive sealant itself. To include things, as I mentioned, like compatibility in the various different system components that are involved in structural and non-structural glazing applications. Along the way, we're going to be reviewing some of the differences between the sealant technologies. We'll focus on moisture cure adhesive sealant technology, which is primarily utilized in curtain wall systems, exterior perimeter weather seal applications, around doors and windows, around for control joints, expansion joints, and the like. Many of the types of considerations that we're going to review for structural systems are also going to be relevant for your non-structural applications as well. So we will also review some of those joint designs. The importance of understanding the various different accessories and other system components that go into curtain walls, along with the installation, the items that are going to be complementary or rather just part of the installation process, such as the backer rod material and setting blocks and temporary pressure plates and so forth. We'll be reviewing those. There's a few different ways that we can do some on-site testing to ensure that you have a high performance application for your joint seal and or for the adhesive bond between the insulated glass units, the IGUs, and the mullions or framing of a curtain wall application. And then we'll also review a little bit about the 079200 spec in terms of some of the nomenclature that you should be on the lookout for. And of course, as I mentioned, whether it's ADFAST or any other manufacturer that's in this space, please do reach out to ensure that your master spec for this section is up to date and current with some contemporary methods for and considerations for both the preparation and then the installation and the testing of these joint seals to ensure that we're going to have a durable and resilient design and ultimately building for many years to come. So much of this we discussed in our Making Sense of Sealants presentation. That's another one of the 3 presentations we're currently bringing to the specifier market. So for those of you who have attended our Making Sense of Sealants presentation, this will be a little bit of a recap, a refresher, but I will touch base on it in case some of you have not been. When we look at the different types of sealant technologies, there are those that are curing by way of drying. So these are water-based or solvent-based type of adhesive sealants that are they're actually going to have water or solvent that's going to be baked in, so to speak, within the production process. And the way for these to cure is actually it's through drying. And when the water or the solvent is evaporating or flashing off so it can go through its drying process, we're actually losing some of the structural integrity of the bead itself. We're losing some of the volume of the bead of seal. Up to maybe 30 or even 40% of the bead can actually evaporate. And so what we're left with with those that are actually curing by way of drying is a bead of sealant that is got a lot of micro cracks and fissures, and really it's sort of shrunken down to where it's not going, and hardened in some respects to where it's not going to be able to handle joint movement as much. This is why in applications for building facade glazing and for many other types of building envelope applications for perimeter weather seal around doors, windows, expansion joints, control joints, and the like, is the preference is going to be to use a moisture cure adhesive sealant. And that's what we're looking at here on this slide is silicones, hybrids, and polyurethane sealant technologies. And when I use the phrase adhesive sealant, this is really more of a spectrum because there are some that are intended to be much more their primary purpose is much more along the lines of adhesion, something similar to what we would see with a structural neutral cure silicone that would be used for structural building facades, curtain wall applications. And then there are those that are intended much more to maximize their elastomeric properties. So that would be similar to that of like a low modulus neutral cure silicone, which is going to offer still excellent adhesion and great compatibility, but more movement. And those would be more common in expansion joints. So we will be taking a look at some of the various different applications for these types of sealant technologies. There are a couple different types of silicone families, very important that we understand because there are some that should be utilized in the interiors and then those for the exteriors. And then we'll take a quick look at some of the advantages of silicone versus polyurethane. However, and I've been with AdFast now nearly 6 years, and when I first began, there was still a big push, by AdFast, by many others, in this space, who were working to get the spec changed out from polyurethanes to silicones because the silicone of new, not the silicone of old, but the newer neutral cure silicone is a better overall tech for these types of applications in a polyurethane. So once again, we all, Dow, Sika, Tremco, AdFast, everybody's bringing polyurethanes to market, but we recommend them for different applications than what we're focusing on here today. So one thing to keep in mind for your structural applications, whether it's a two-sided or four-sided structural curtain wall, it's going to be sort of a hard spec requirement to use a structural neutral cure silicone for those applications. This is going to be where we're adhering the insulated glass units to the framing. So when we're looking, and I'll have some pictures upcoming that will show both the two-sided application, the four-sided, because there's going to be some differences there. There are a couple manufacturers, including AdFast and Dow. So like a Dow 795 would be equivalent to our AdFast 4580 that are actually approved for a two-sided structural curtain wall application. So in those instances, we don't have to go with the structural neutral cure silicone because a weather seal silicone that's a class 50 with an AdSeal 4580 or a Dow 795 type of product is actually going to be sufficient. For all others, and especially for four-sided applications, the structural neutral cure silicone is actually required. There are some two-component sealants that are available for on-site glazing. However, for the most part, two-component sealants are going to be utilized in a fab shop. This is where they'll look for speed because, as we'll see in some upcoming slides, the structural silicone needs to have ideally 21 to 28 days for full cure. But when we're introducing an accelerator, a promoter, a booster of some sort into the mixture, then it'll actually go through the curing process much more quickly. So in prefab application, there's going to be an opportunity, for example, in the actual production of insulated glass units where they're doing the seal, the secondary seal around the unit. This will be a structural silicone, and they'll actually use a two-component most often in the fab shop, in the production facility where they're making the insulated glass units. For weather sealing expansion joints and perimeter joints around doors and windows, it is recommended to use a class 50 neutral cure silicone or greater, and this is going to help you achieve a much greater lifespan, much more robust and durable joint sealant for many years to come. For 50 plus years is what you can expect when using the appropriate class 50 neutral cure silicone versus that of maybe 5 or 10 years with a polyurethane or maybe 10 to 20 years with a hybrid. As it relates to the two different types of silicones that I mentioned, the acetoxy silicones, which for us we call it our 4800 KB for kitchen and bathroom. The other manufacturers have a similar product in this category, which is going to be it's curing by way of it has acetic content in it, and so it's curing, and as it's evaporating, it's flashing off a little bit of that content, so there's a little bit of a vinegary smell to it. However, once that dissipates, it's not a long-term issue. It's just that you're getting that vinegary smell due to the acetic content. The acetic content is in there to actually assist with some of the mold and mildew resistance because unlike the outdoors exterior applications where we have constant airflow within a limited space, such as in kitchens and bathrooms where we are introducing moisture but have less airflow potentially than what we do outside, it's really helpful to have that additional help with mildew and mold resistance. Now, one of the drawbacks, though, and the reason why this wouldn't be able to be used outside or recommended to be used for exterior applications, is that it's, we're actually going to have much more limited range of applications that we can utilize this in, because of it's going to adhere to less materials in terms of compatibility of adhesion. It has much less movement capability, so it's not going to move with joints. So especially if it's dissimilar materials, they could have different thermal coefficients ratings for movement. We wouldn't want to use that. This is more for your around tubs and toilets and sinks and countertops and so forth. On the other side, the neutral cure silicone technology, which is much more advanced than the silicones of old. This is really the ideal product for your residential, commercial, industrial applications as it relates to both structural and non-structural caulking. Much more compatible as well with an acetoxy silicone due to that acetic content. For example, on unfinished metals, unpainted unfinished metals, there could be some corrosive challenges there with that acetic content. The neutral cure silicone is going to be the most compatible. It's not going to cause staining across probably 99.9% of the various different substrates. And for those really hard to adhere to substrates, there are primers that interact really well with the silicones, and you can get a long-lasting application that way. So what's the primary reason why the market shifted from polyurethane to neutral cure silicone? And there are several different reasons. However, the major one being that polyurethane, since it's organic in composition, is actually breaking down quite quickly with exposure to UV light. And UV light is, going to degrade anything that's, chemically composed material. So it's going to, actually have a much lower lifespan than that of a neutral cure silicone. Neutral cure silicone is inorganic in composition, and therefore a little bit more resilient, and in fact, quite a bit more resilient than that of a polyurethane to those UV rays. Here's an example of a bead of neutral cure silicone on your far left, and then in the center here is a bead of polyurethane that was, this picture was actually taken on the south side of a building. So, here in the Northern Hemisphere, I'm coming to you from the Chicagoland area. This is where we're going to get the most sunlight. It's on the south side, generally speaking. And so those joints are going to fail much more quickly than those on the north. Again, here in the Northern Hemisphere. But you can see here the bead on the left, the neutral cure silicone is, been in place for many years and is still intact. It does not shrink. It's not going to crack and start to degrade like the polyurethane will. So something to keep in mind is that you're typically getting about 5 to 10 years on a polyurethane, whereas you'll get closer to 50 plus years from a neutral cure silicone, as long as it's the appropriate sealant chosen for the application, it's installed properly. One of the things to keep in mind regarding a polyurethane is that because it's organic in composition, it's actually going to be affected quite a bit more by the ambient temperature and climate conditions. So when you have a polyurethane, what's pictured here is we call it a sausage gun. It's there's an aluminum foil pack of sealant that's about 600 milliliters or 20 ounces of sealant, which would be double that of a standard cartridge. So this is very popular in commercial construction, and residential contractors are actually starting to pick this up quite a bit as well. And so what you see here is a sausage gun. And what happens in the cold weather conditions is that oftentimes a contractor will have to warm up a polyurethane before applying it, because it gets too dense, it gets too difficult to gun out and to extrude. And the challenge with doing this is that if the substrates are cold, which we know that even if the air temperature rises, the materials such as especially the brick here that's pictured, will hold that cold temperature well into throughout the morning into the day. So if we're warming up this adhesive sealant, this polyurethane, in order for the installer to be able to gun it out more easily, we're now introducing a warm sealant to a cold substrate, and that's going to, in effect, cause some condensation to form. And this is this is actually one of the biggest culprits for delamination of a bead of joint seal, is at least for moisture cure adhesive sealants, is that we're introducing moisture prematurely to the backside of the bead. Whereas the other types of adhesive sealants, if they're water or acrylic based, or solvent based, once again, they're drying, so they're curing from the inside outward. Whereas a moisture cure adhesive sealant is curing from the outside inward. It's drawing the moisture in, and it'll cure, slowly over time. Usually it takes about 24 to 48 hours for full cure to go to a depth of about 1/2 of an inch. It'll start to skin over, especially if using a neutral cure silicone, a little bit more quickly than that. But what we aim to share with you all with this slide is that a neutral cure silicone, since it's inorganic, it's not going to change consistency. So the installers, in fact, don't need to warm up a sausage. They'll be able to gun it out just the same in very cold temperatures as they would in warmer temperatures. So there's a major benefit there to using a neutral cure silicone, and much less worry that about moisture being introduced to the backside of the bead and causing it to cure before the cross-linking adhesion can take place chemically between the two different substrates. On the other side, here at the bottom of the screen here, we have to address in warm temperatures. Warm temperatures, it's the opposite. So solvent-based adhesives and also polyurethanes are definitely the types of adhesive sealants that are going to be affected the most by hot temperatures, especially extreme heat, like we would find in the southern United States or in Mexico. This is where, especially for your vertical or overhead applications, installing a bead of sealant and tooling it into place may look okay when the installer leaves. However, they come back the next day and it's pulled out of the joint cavity, or it's sagging or dripping down. And even if we're not seeing it, a great deal, visually from the exterior of that joint seal, there is a chance that on behind, or deeper into the joint cavity, there could be some sag. And what the problem this creates is that as there's movement between the different substrates, if we don't have excellent contact or engagement of the adhesive sealant with the substrate materials, it's not going to be able to withstand that movement over time, and therefore it'll start to pull away or crack, and then you've got joint sealant failure. So we need to ensure that there's not going to be this sag caused by the sealant, like a polyurethane or thermoplastic or other solvent-based adhesives that will be affected by the heat and become runny within the joint cavity. The drying time that I mentioned, I think I mentioned skin time or tack-free time as well in my previous description. This is where we can actually take our finger and place it onto the bead of sealant and remove it, and the sealant did not adhere to your finger. This is when it becomes tack-free. These are adhesives, so they are going to be tacky. But once they become tack-free, there's a great advantage, especially from an aesthetic standpoint, in that job sites are dirty, right? There's a lot of dust and debris floating around, and anything that's landing on a bead of sealant while it's still tacky is ultimately going to become part of your project, right? It gets baked into the final project. Whereas with a neutral cure silicone, which is going to skin over much more quickly, it could be as fast as 15 or 20 minutes, even depending on heat and humidity conditions. But this is where the benefit you have is anything that lands on it after the skin time, even though it's still going through its curing process, once it's skinned over, it becomes tack-free. Anything that lands on it, when we get to final building turnover, we're doing a final power washing and wipe down, to display the project. Anything that landed on on that sealant post tack free time is going to be wiped right away. Versus a polyurethane that could take many hours or many days to actually go through that tack free time. So anything that lands on it during that time frame could become quite a bit of an eyesore. Just something else to keep in mind. All of us manufacturers still bringing polyurethane to market because it has its place. We use it primarily for hidden adhesive applications. It's a great adhesive and across many different types of substrates. But it's hidden because there can be some staining that can take place with polyurethanes. It can sort of leach into especially if it's porous. If you're working with stone or concrete or other types of brick and masonry items, there could be some issues with staining of a polyurethane. But if it's a hidden adhesive application, that's not going to matter. Most importantly, though, when it's hidden, you're not actually going to expose that sealant or adhesive sealant, to UV light, so that it's going to last for a long, long time. So it is a little bit less costly than that of a neutral cure silicone, but the neutral cure silicone, which is a newer technology of silicones, is offering excellent adhesion and great compatibility and much more resilience to the UV light concerns that we talked about for polyurethane. So that's why it's primarily being recommended for these types of applications. Let's take a quick look into curtain wall systems. There's pressure plate system, two-sided structural systems, and four-sided systems that we'll briefly review. Those that are actually going to be mechanically retained will not require any type of structural silicone. So as you'll see here, these units, oftentimes this is done in a fab shop too, and sort of trucked out and then craned into place or it can be done on site, installed on site as well. It's very common for storefront, as we saw from the last picture here, where you have no chemical adhesion required. It's all mechanically retained, all along the curtain wall. When we get into two-sided systems, and this is a great picture to illustrate it, you're actually going to see, and oftentimes it's at the deck level, floor level, where you might have some mechanical fastenings, but then on the vertical joints, there will actually be a chemical adhesion to the framing members, the mullions that are here for the curtain wall. And so that's why we call it two-sided structural silicone adhesion. And here's an example of that, where we still have mechanical retention here, in this case along the horizontal plane. And then on the vertical joint, we're going to have this structural adhesive, which is a structural silicone. And I'll pause it here so we can get a closer look, but I will have more on the next one too. Whoops, went too far. Well, I'll have it on the next one as well. So you'll see it here on the four-sided. So as you can imagine, with the four-sided, there's no mechanical retention whatsoever. So there will be a requirement for temporary pressure plates, as you see here. These will be installed at the time that these glass units are being placed. And then these will remain in place for about 21 days after the structural neutral cure silicone has been installed on the back side of these glass units. So here is a diagram to show this application, where you have your framing member and then your insulated glass unit. You'll see here that, and I referenced this earlier, the secondary seal, which is in yellow in this diagram. For structural applications, this needs to be a structural silicone as well. And this is where that two-component structural silicone is more common in production of these insulated glass units, because they'll want, for handling time and so forth, they'll want these to cure quite quickly. The green is actually usually some sort of butyl, and then you'll have a spacer in here with some desiccant material to help, it helps to mitigate moisture. getting into the cavity here. So what we're primarily focusing on here is the structural silicone in blue. In black is going to be a spacer there that's going to help to set the depth and the width of this joint cavity. It provides some conformity all across the project as well to ensure that the wall's nice and flush. But we do need to ensure that there's going to be a minimum 1/4 of an inch of contact between the glass pane. In this case, it's the face of the glass here, along with the edge of the front edge of the mullion. And we're going to tool it into place, and it's going to have a little bit of concavity here. And when it's actually tooled into place like that, pressed into the joint cavity, what we're doing is we're ensuring that we're forcing the sealant to the outer edges of the joint cavity to engage 100% with these two substrates. And so when we're pressing the center, we force it to the outside. Very, very, very important. This is what's called structural bite. We need to ensure there's 100% engagement and structural bite alongside these substrates. And then the spacer here, similar to that of a backer rod material, is actually going to be some sort of polyethylene type material, where or Teflon type material, where it's the adhesive sealant, the structural silicone, is not going to adhere to this block here. So very, very low surface tension. It won't create a bond here between those two, which is ideal, because what we want to do is maximize the movement potential between these two. We don't want to anchor it to a third product, a third material. The backer rod, this would be a soft open cell bicellular backer rod, meaning that it's it is soft and open cell. However, it has a membrane all the way around it to help prevent water from permeating through. That's the one advantage of a hard closed cell system over that of a soft open cell system is its permeability. However, with the backer rod that's bicellular, which is what we bring to market primarily, and should be a hard spec requirement for this application, is a bicellular soft open cell backer rod, is going to have a membrane all the way around it to help prevent that water from going through, the moisture from going through. So that's a little bit more of a deeper dive into that particular application. We will take a look at a few more applications for structural, then we'll dive into non-structural and finish up with some compatibility considerations. So when we're looking at pre-glazed applications, I mentioned before, this is usually done in a fab shop. There are some benefits to speed and also with quality control and so forth. Oftentimes this is automated, so there's some robots that are programs to put the appropriate amount of sealant into place. However, cranes are needed to be on site in order to lift those units into place. Oftentimes we're seeing on-site glazing. This is where a single component adhesive sealant, similar to what we saw earlier in the sausage gun, is going to be utilized to go ahead and install that adhesive sealant on site. One of the drawbacks to this, we have to be more mindful of temperature and humidity conditions and make the appropriate adjustments to the length of time before we can remove those temporary pressure plates. So there is some planning that needs to take place, especially as it relates to the other trades. Sometimes these construction projects are tight, and we have one trade pushing another around a building, or we're looking to get something enclosed very quickly to remove lifts from the site, remove cranes, etc. We need to ensure that there's going to be enough time for time allowed, usually 21 to 28 days, for that structural silicone to go through its full curing process. Just a quick look here into some of the ASTM testing that we're doing in our laboratories. These are standardized tests that all manufacturers are conducting, whether in their laboratories or through third party or both. And primarily, we're going to be conducting these tests to be able to provide the results to you all via the technical data sheets, the safety data sheets, and so forth. So you can do a side-by-side comparison to determine which adhesive sealant is going to be most appropriate for your application. C1184, the specifications for structural sealants, actually includes several of these, such as the 1135 and the 794, which are very, very important tests along with some of the others. You know, the hardness, or what's called the shore A of an adhesive sealant, is going to be determined by way of a durometer. So that's going to determine in many ways how you know, the hardness of a sealant is going to determine or give some indication as to its the elastomeric properties or benefits you'll be able to gain from it. So those that are finishing harder and less elastic will be intended more as an adhesive, whereas those that are soft or more pliable, stretchier, those are going to be used more for you know, expansion joints and so forth, where you have a high degree of movement expected. We do these sort of tests at different types of, you know, with different types of climate conditions, mimicked as best as possible within the laboratory. So there's UV testing chambers. There, you know, where there's freezers, there's ovens. It goes from, you know, goes into water, then it goes into a freezer, then goes into oven, and vice versa. UV light is, you know, applied to these, you know, not just to see what happens to the integrity of the sealant itself and the bond, but also with other things in mind, such as staining, because this is, you know, UV light is actually one of the things that can, and heat in general can and moisture too, by the way, can cause things like staining in porous substrates. So ASTM C1184 is a very important test, and you should note that within the technical data sheets that you're referencing for your products. C794 is also included in that 1135 testing, and this is where we're actually curing, in this case, a structural silicone to the pane of glass, and there's a mesh here that's been cured in place as well, and then we're pulling back on it at 180 degrees to determine the adhesion as we're peeling it away. In this case, this is what's going to be called cohesive failure versus adhesive failure. So this is a pass. You know, just like a rubber band will eventually, you know, will expand, and eventually you can break it. So too, you would have that with these types of adhesive sealants. You know, they're designed to take so much movement. So you will achieve cohesive failure at some point. But what we're looking for is that you're not going to have adhesive failure. In this case, the intention was to test whether or not this particular adhesive would adhere to the glass under those conditions. And obviously you can see that it actually broke apart before losing that adhesion. So that's a good sign, because you normally wouldn't have those type of forces, especially at 180 degrees like that on a typical project. In terms of structural curtain walls, there are a few things to keep in mind. Most of this I've already mentioned, so I'll go through these next few slides a little bit more quickly. The bite to thickness ratio should be between 1:1 and 3:1. It's usually calculated by an engineer, because the size of the units are going to, and also some of the other conditions, such as, you know, regional wind load, for example, is going to contribute to these calculations and ultimately the decision on what type of joint configuration to use. So, for example, here, you know, when we'll have a few different examples to show, but this one in particular is going to show that structural bite that I referenced, which is going to be the adhesion, you know, from the sealant to the actual mullion and from the sealant to the pane of glass for your structural applications. Very, very important. I talked about the secondary seal already. From a thickness perspective, I also mentioned a minimum 1/4 of an inch and maximum 1/2 of an inch. So that's what's expected for these sort of applications. As mentioned, usually it's going to be working in coordination with the engineer for the project to understand regional wind load as it relates to the size of the actual unit itself. Usually the longest short span is the factor that's taken into consideration for those types of projects. The joint configurations, it's very, very important that it's in accordance with ASTM C1249 for the insulated glass. So once again, the secondary seal will need to be a structural silicone as well for those applications. When you're working with non-structural applications with insulated glass units, it does not have to be a structural silicone, but we do recommend a neutral cure silicone for primarily for reasons of compatibility, but also because of the breakdown that can take place due to UV light. Here's a quick few joint configurations for you all to keep in mind, and we'll be making available a copy of this presentation so you can refer back to it if you have any questions. Once again, we have your framing member, we have the insulated glass units coming into place, a setting block, and then we're going to have usually there would be a temporary pressure plate here to retain these insulated glass units. And then once those are retained in mechanically, we will install a 1/4 to 1/2 inch bead of structural silicone. We will tool it into place to ensure that we have maximum engagement across the walls of the joint cavity here. And then we will, at that point in time, after approximately 21 days, around 72, 73 degrees Fahrenheit, and about 50% relative humidity are the general conditions. We can go ahead and remove the temporary pressure plate, and then we'll install this soft open cell bicellular backer rod and come back and finish off with the perimeter seal, which will be a class 50 neutral cure silicone, similar to that of so ADFAST 4580 or a Dow 795, Sika 295, Tremco Spec 2, Pecora 895. These are some of the more common ones in the market. There are some situations in which you would not utilize a weather seal for the perimeter because the structural silicone will double as the perimeter weather seal. So in this case, we are just going to, there's a sort of a protrusion here from the edge of the mullion. And so now we're, as opposed to adhering from the face of this glass pane to the edge of the mullion, now we're actually adhering from the edge of the IGU to the face of this part of the mullion. One important thing to keep in mind here is that if you're working with a non-rectangular, we do want to try to maintain a 90-degree angle. So if you have a non-rectangular joint, this will be helpful in terms of movement, over time, because we're going to have some, whether it's seismic, or usually it's wind if it's some sort of tower project, where you want to be able to maximize, it's not static. It's going to be dynamic in terms of some movement. And that's why a structural silicone is ideal over that of, a lot of other great adhesives out there. We bring a lot to market as well for a lot of industrial production and manufacturing types of applications. However, we want to have a little bit of movement and excellent adhesion. And so that's why a structural silicone is the way to go. Interesting application here. This is where you're going to have, one unit coming to another. And what we would do here is we would apply some sort of, whoops, I went too far, sorry. We would apply a little bit of an anti-adhesive tape, so polyethylene or Teflon type material on the back side here. Then we can tool it into place, come back, remove the tape, and then tool that into place from the other side, and then you'll be good to go. So we'll need to use the tape as sort of a backing material, but once again, it should be anti-adhesive tape so that you don't have to worry about peeling it away later on. Here's a quick diagram to showcase the few slides that we just covered. So you have your framing member, your Norton type setting blocks, and then your insulated glass units are coming into place. You have your mechanical fastening, your temporary pressure plate that was in place while the installation of the neutral cure structural silicone was being accomplished. And then after that had cured for about 22 days, under favorable weather conditions, we've got to adjust if we're going to have other conditions outside of that. If there's much less humidity or much less heat or both, it may be closer to 28 days than the 21 days. So those are the different components that we'd be working with for this type of application, along with setting blocks. So setting blocks are not in here, but I've got another slide coming up when we talk about compatibility for setting blocks that will be placed on the bottoms of these units during installation. A lot of verbiage here. All it is simply describing what we've just discussed over the previous slides. So very, very important as well to ensure that we're cleaning with isopropyl alcohol. So I don't think I mentioned that. So 99% IPA is what's recommended. 20 minutes is a heck of a long time to wait for this to cure, for it to evaporate. Usually IPA is evaporating pretty much instantly. So we just want to make sure that there's not going to be any remnants there of the IPA, or at least not in any meaningful fashion that would interfere with the installation of the sealant itself. So it should be clean and dry. IPA is going to help wipe away not just dust and debris, but also oils. So some of these materials that are coming from the fab shop, are going to could have some oil on them, right? So we need to make sure they're oil free. We need to make sure they're dirt free, dust free. And we need to make sure they're moisture free. So that means that at the time of installation, they're free of, other types of moisture, frost, dew. If it's just rained, it needs to be clean and dry. Is one other thing to keep in mind. This guy's going to be okay, I assure you, but close call here. This is the reason why it's so important to make sure that we're doing this application correctly. Okay, let's take a very quick look at non-structural applications. We can go through this a little bit more quickly because we've just discussed most of the things that are going to be, most of the things that are relevant in structural are going to be the same case for non-structural applications. So there are some different types of joint designs because now we're working with other types of substrate materials, but we're still looking at a minimum of 1/4 of an inch, maximum 1/2 of an inch. That's what you're going to find across the board with moisture cure adhesive sealants in general. So we're still tooling it into place, so you'll have that concavity there. Still using a soft open cell backer rod, and lots of different types of, whether it's substrate to substrate or they're dissimilar materials. We do need to understand the type of movement that could take place there. So the movement of a large scale, I think like an 8x4 foot, ACM panel is going to have a lot more movement, especially side to side, if it's, installed horizontally, than what some other materials, may have that don't have quite as much movement in them. So very important to keep this in mind. Class 50 neutral cure silicone is recommended for all of your weather seal applications. This is where we don't want to use the polyurethanes. Hybrids would be an acceptable alternative. Hybrid technology, which we haven't discussed too much, is something that's being available. Hybrid polymers, MS polymers, or modified silane polymers, or STPEs, which is silane terminated polyethers. These hybrids are coming to market. There are class 50s that are available, and they're paintable, whereas neutral cure silicone is not paintable. So something to keep in mind there, that you still want to go with class 50, whether it's a hybrid or a neutral cure silicone. For class 150 expansion joints, we want to go with, this would be a low modulus neutral cure silicone. For example, that would be an AdSeal LM 4600, or comparable would be like a Sika 290, Dow 790, those Picor 890. These are some things that come to mind for, or in Tremco Spec 1 for the class 100/50. When we're working with non-structural curtain walls, we do need to ensure that even if there's not space for a backer rod, we still use an anti-adhesive tape to ensure that the sealant is not going to go off into some deep, dark abyss. We need to intend or ensure rather that it's going to adhere to the when we're pressing it in, that we'll be able to maximize the adhesion to the substrates. Of course, when a backer rod is available, we want to go with that soft open cell backer rod. What's recommended for waterproofing and movement joints is going to be a 2-to-1 ratio in terms of width to depth. So, you know, if we're going, ideally, if we're going up to like, say, a 1/2 inch in depth, you know, up to 1 inch in width is ideal. However, there are some applications where I've seen 2-3 inch joints before, large expansion joints. And it's not ideal. However, we still need to shore it up to secure it from moisture and from insects, and to keep warm air where we want it, whether it's outside or inside. All the reasons why we need to keep to go ahead and seal it. There are some applications where you can go much wider. However, you're never going to go deeper. So we have a 4-inch backer rod that would be used for maybe up to like a 3-inch wide gap because they're compression fit. So they're compressed down and tooled into the joint cavity at a specific depth. And that's where we want to ensure that we're using an open cell system so that if it's punctured during that installation, it's not going to cause off-gassing like a closed cell system would. The ASTM testing, this is where we have quite a bit of ability to assist you all if you have some questions regarding any of the ASTM tests that are made available to you all. The test results are made available to you all via the technical data sheets and safety data sheets. But some of the nomenclature here, as we're looking at elastomeric joint sealants, we talked about singular multi-component, so that designation will be there. SAG or pourable, or we refer to it more as self-leveling type sealant, so that indication will be there. Along with, on the far side, all the different types of, what's it's intended for, what are the different components that will be involved, and then the class system. We talked about, this is through what's called the Hockman cycle, ASTM C719. It's determining the movement capability, so the elongation and the compression of this elastomeric sealant. We will recommend a class 50 and greater for both commercial and residential projects. Usually we're finding that a class 35 is often recommended in residential, and class 50 or greater is usually spec'd for commercial. We are recommending for everybody to go, there's not a large cost difference, if any at all, between a 35% and a 50%. So we're recommending the 50%. It's going to offer much more movement. Therefore, it's going to last a lot longer, and it could be double or triple the lifespan of that of a 35%. There are many tests that we're doing as well in terms of ASTM that is going to help determine the tensile strength, the structural integrity of the sealant itself, as well as that movement that we talked about to determine. It's always going to want to come back to its homeostatic state. That's the benefit of a neutral cure silicone. However, it is going to allow for a great deal of movement, especially those that are low modulus, that are going to offer 100% elongation. We can't get to 100% compression, so that's why it's still a 100/50. But it's one of those sealants going to provide a high degree of movement and excellent adhesion and good compatibility. Hardness we discussed as well, so something else to keep in mind. The harder it is, the more likely it's going to be used for an adhesive project. And then here's some examples of some staining that can take place. Okay, a lot of verbiage here. Again, you'll have a copy of this of your presentation, but similar to that of the structural application. We do offer a suggestion in terms of using a solution of 5% clear dish soap and 95% water for the tooling sticks. For the tooling sticks, you're able to soak them in these containers of 5% clear dish soap, 95% water, and it helps with the tooling aspect of it. You'll see here this installer using a tooling stick that's been soaked in that solution. It makes it really easy to slick there. So very, very important to tool your beads into into place. And I do need to point out lastly here, of course, we can do some on-site testing for you all. So reach out if you have some interest in that, especially, at the mock-up stage would be most important. We do have a full presentation around compatibility. So this was a little bit more of a teaser here. So please be on the lookout for that. We do that through ATS as well. I mentioned that for the secondary seal, you can use a other than structural silicone for your non-structural insulated glass unit secondary seal applications. However, it should be noted that when you're using a non-silicone, you don't have to use a structural silicone. We just recommend a neutral cure silicone. There can be some issues with compatibility with the setting blocks. So setting blocks is where we can have some incompatibility here. And it's very, very important that we, you don't want to have that across your project. So keep us posted, please, if we can assist with, 079200 or 084413. That's for joint sealants and also glazed aluminum curtain wall applications. We'll be glad to work with you all. And there's no cost to you. We're very consultative in our approach and direct to market. And then if you'd like to have a copy of a color chart sent out to you guys, that we offer over 400 different colors in our neutral cure silicone and counting, just indicate it so in the comments, and we'll be glad to ship one out to you free of cost or any samples that you may like. So thank you all for your participation today. Appreciate your time, and I'll look forward to connecting with you in the future. Thanks, Fulgens. I'll turn it back over to you.
Thank you so much, Dan. Excellent presentation as always. Appreciate it.
Thank you, sir.
Thank you. All right, everyone. There is a session code for building facade glazing 137184 that is available for you in the chat as well. If you would like the color chart to be sent, please send that message in the Q&A panel, and we'll make sure we add it to the report so Dan can receive that. In addition to your questions have been added to the Q&A panel for Dan as well. All right. And at this time, we are moving right along with our agenda for the day. One moment here. Let me stop sharing here. I'd like to introduce you all to our next presenter here to present sustainable exterior envelope. Please welcome Bill from Windsor One. Bill, hello, how are you? Oh, you're muted, my friend.
Gets me every time. I should have this down by now.
That's all good.
Well, good morning, everyone.
Good morning. Whenever you're ready, Bill, go ahead and share that screen. Somebody, you just said yes, please, for the color chart, but you posted as anonymous, so we will not be able to send you anything. Please repost as non-anonymous. Thank you in advance. Just please repost your question or your request as non-anonymous. All right, Bill, it is all set. Take it away.
Awesome. All right. Well, hello, everyone. Thanks for the time. My name is Bill. I'm with Windsor One, here to walk you through some good tips on a sustainable exterior envelope. Really, what we're going to focus on today is kind of putting wood back on the menu. So I know a lot of builders and architects have shied away from using wood for trim and exterior projects, and I'm going to walk you through today some great ways to get back to building the right way and how to select the correct products to be able to do that and feel confident. So we're going to break this up into a couple different areas. We're going to talk about the biological effects on wood, durability, environmental effects, and then what we can do to really get a lasting project, and then talk about prolonged durability. So some of the man-made efforts that we have done to allow these products to even last longer. So first, we're going to jump into the factors that affect the durability of woods. So I'm talking about molds and funguses and insects. So the most common biological agents, these are going to be those three. Now, all of these factors, they're going to can greatly diminish the durability of wood products. and can potentially result in a failure in the field. So there's a lot of great things we can do to mitigate this. So we're going to talk a little bit about them first, so you can kind of learn a little bit, and then you'll see why it's so important to do some of these best practices to help avoid this. So when you look at wood, wood is a biological material consisting primarily of cellulose, lignin, and hemicellulose. Now, these structural polymers are what makes wood such an amazing building material, but also that's where a lot of the sugars and the food source for the tree is stored. So essentially a tree is if you look at it, basically just a bundle of straws. And in those straws is going to be all your water and then those complex sugars we were talking about. Now, when the tree's alive, the bark does a great job. It's kind of like your skin to protect the tree and keep it protected from these molds and mildews. And I don't know how crazy everyone did with COVID and sourdough, but I definitely took a go at it, and I did lay the bowl of flour out in the countertop with some water in it and naturally colonize the molds and yeasts in the air. And they're always there, whether you're interior, exterior. So we want to make sure that we are protecting our products. So the next one we're going to talk about, let's look at the funguses. So what can be very interesting, and what I like about this picture, is you're seeing this type of fungus growing out of this portion of the exterior envelope of a building. Now, what you can't tell, though, is this fungus may not actually be growing on the wood itself. It may be growing off of debris that's stuck in that crack. So this is also just another good opportunity to show some of the things we want to avoid so you don't get problems like this. So funguses, some of them are going to feed off of a living tree, and some of them are going to wait until you've got, decaying, already kind of cut and rotted lumber. So there's different types, and they can tell you a little bit about what's going on in your current situation if you see them. So now all funguses really have four basic requirements for growth. We need a suitable temperature, oxygen, food, and moisture. Now, if you eliminate one of these things, you can prevent this fungal growth. Now, mold and fungus have a very broad temperature requirement, but most grow best at a temperature between 75 and 80 degrees Fahrenheit. Now, most also require oxygen to function. In fact, one method from preventing this is when lumber and those logs are cut down for forestry, they're going to store those logs in retention ponds, or they're going to spray them down regularly with sprinklers. So momentarily, that water can help keep the oxygen essentially off of the surface to slow down that process. Now, what's also great about wood is because of its chemical structure or its makeup, it is great at getting wet and then drying out over and over and over again. Where we start to running into issues is when things retain that moisture. That is the biggest problem we've got. So next, we're going to jump into insects. We've got a couple different types. So you can think about carpenter bees, carpenter ants, termites. Some of them make their home in the wood itself, and some of them actually eat it. For instance, termites have a kind of a complex bacteria in their stomach that allows them to actually digest the wood fiber. Now, not an ideal situation. We'd like to prevent this. So when we talk about preventing pests, you have physical barriers you can use. We can use pesticides, and you can also, select products that have a resistance as well. So as wood can age, if it's not installed properly, stored properly, or selected properly, you can start to get some issues with it. And we're going to go through those because they're very important to kind of understand the bigger picture of what's going on. So when we look at, say, shrinkage, you've got those bundle of straws that I talked about. When the tree gets wet or the lumber gets wet, those straws absorb water and they will increase in width. You cannot really stretch them out. So when lumber gets wet and a lot of other building products, they're going to get wider. Now, that can show you that you've got some movement. So for instance, inside of these columns typically is a 4x4 or a 6x6 piece of treated lumber. And that lumber has now sucked in a bunch of moisture and expanded, causing all these gaps to open up. And on the other side, you can get is when something can be installed and it's going to lose moisture, and then it's going to, shrink on the boards themselves. Now, when you look at, say, this picture as an outside miter, that 45 degrees, this can tell you a lot about where that gap is on what's happening. So for instance, like I said, the cross grain shrinkage, the wood is going to shrink in width. So the fact that that inside joint has opened up on the inside means that we are drying out. That board is getting smaller in width. If that opening was going to be on the other side, that would mean that it was gaining moisture and increasing in width. So when you're increasing in width, you're gaining that moisture, that's swelling. And in a lot of applications, you can easily mitigate it. So we look at this picture here. This is a very long patio cover using a T&G style ceiling pattern of lumber. And what's going to happen here is this wood was either not allowed to acclimate to its new home properly, so to kind of reach equilibrium with its new moisture content of surrounding area, or quite often what can happen is you could have a roof leak and you're introducing moisture to that space. So what's happened is these boards are getting wet and they can expand 0.5% in width. Now, that may not sound like much, but when you've got a 100-foot long run of almost 200 boards, that 0.5% adds up. So simple things we could do here, the width of a credit card in between those boards when you're butting them together can sometimes be all that's necessary to avoid something like this happening. So warping is the next one we're going to talk about, and there's a bunch of different types. There are two that are really, in my opinion, the most important. And that's going to be a kink and a cup. So from a kink, this is going to be the only one that is not caused by the outside environment. This is a manufacturing defect. And how that happens is when this lumber is cut and harvested from a tree, most often they're going to cut out knots and defects. Now, when you cut those knots and defects out, if you don't leave enough of a margin, meaning that you're cutting too close to it, you've released this bound up pressure inside of that tree, and you're going to get that localized movement. So this is where it's, a shout out to my company, Windsor One. It's very important to select a quality manufacturer that's going to take these steps to avoid this. The next one is going to be a cup. Now, why a cup is so important is a cup is going to be most often a differential in moisture on the top and the bottom. So if it's cupping up almost like a bowl, like you can see in this picture, that's going to mean you've got more moisture on the backside, or if you look at maybe decking, you can have a bunch of trapped moisture underneath, which is building up and causing the bottom of that board to expand, and the sun is baking down on the top, drying it. So you've got this unequal force that's causing the board to cup. So that's a really good way to know if you've got something going on seeing a cup. Now, it could be opposite as well. It could be too dry underneath, but it's just going to tell you you've got a moisture problem. Checking is a very common thing that's going to happen with both lumber and some synthetic products as well. And it's completely normal. So as this lumber is drying out, those straws, like I talked about, can separate a little bit. And that's perfectly normal to kind of help protect that depending on what the application is. You can add a single coat of primer on that end to just kind of clog up those straws. For instance, AAPEI decking, you use a wax. There's a lot of different things you can do to help slow down the moisture. So the moisture is leaving this board, and it's going to leave the fastest from those ends. So covering up that end is really going to help. Now, when it gets a little further, we call that splitting. So if you were to take, say, a credit card and you were able to insert that credit card to any of these splits in this lumber, and the whole credit card will fit in there, there's a pretty good chance that that structural integrity of that beam has been compromised. So while certain applications, people like this look because it's very natural, that's great. But if it's structural, you could have a problem. You've also got the surface weathering of wood, and when things are outside and unprotected. Now, when you look at certain species, cedar, cypress, AAPEI, that's a very desired look. People want that to weather and turn gray or silver. And certain species of wood are meant to do that, and they're more kind of apt for that, but not all of them. So when you start looking at softer woods, pines, things that don't have that natural durability, you can start to get this discoloration, and then you're going to lose the really texture of the surface is going to start to change. Those straws are going to break up a little bit, and then that moisture is going to sit in there. Remember, wood is fine as long as it gets wet, as long as it can dry out. If it's not allowed to dry out, that's when you start getting these problems. You can also start to get surface checking and cracking. And that's why it's so important to look at the climate of where this product is being installed, where this project is. So often customers want a certain look or feel of their project that's not necessarily the best for where they're at. So we really want to make sure we're using the right products, and the most important is we're installing them properly for our client. So chemical agents, not only is this not the greatest picture, but we're showing kind of an ugly problem that can happen. So this is a mismatched fastener issue. So this is called nail sickness. So this is a cedar gate that they use the wrong fasteners, and the wonderful tannins and oils in cedars that make them last outside and make them more of an exterior option for lumber is reacting with the specific metal of that fastener, and that chemical reaction is leaving those trails. So if we've got an opportunity on our plans to spec the correct fasteners, please let's do it. I know we can't guarantee that the builder or the contractor is going to use them, but we have an opportunity, very important, to make sure we're using the right fasteners. So we talked about all these different biological and these aspects that can affect wood. The easiest one that we can control is going to be moisture. Now, if we're using the correct materials and we're mitigating for moisture, you're going to get a project that's going to last and last. I mean, you think about all these products you're using on your project are a reflection of you and your design, and we want them to look the way that you envisioned for a long time to come. And a big part of that is making sure we are doing proper installation and building practices. Now, this one is very, very important, is proper storage. You can have an amazing product that's stored improperly and cause a big issue on the job site. And I have yet to really be at a job site where all of the products were delivered right when they were needed. A lot of times they are going to be stored on site. So a little bit, we're going to dive in on that, the correct way to do that. So when we are storing our stuff on site, yes, we'd love to get it out of water, even undercover, even if it's an exterior product, it's stacked up in bundles, and that's not how it's going to be installed. So you are opening up yourself to trap moisture. So we're going to get that inside a garage, anywhere we can get it out of the weather, but we got to get it off the ground. And that is very, very important, because the ground, concrete, dirt, it's a sponge. It's going to soak up moisture from the surrounding area. And if you've got some nice, dry, beautiful flooring, siding, that moisture is going to get pulled out of the ground and water vapor, and it's going to get sucked right into all that material that you're storing. So I really want to see this product, whatever it is, 18 inches off the ground. That's really going to help. Now, if we can't store it inside and it's got to be stored exterior, we want to make sure we're doing that properly. Now, when you look at a lot of building products that are delivered to a job site, they're wrapped nice and neat like a stick of butter. Now that wrapper that's around that material is meant to protect it in transit. It is not meant for long-term storage and protecting it from the elements. A lot of times it can do more harm than good. So the first thing we want to do is we want to pop open all those staples on the bottom and we want to let it breathe. This is going to do a couple things. It's going to allow it to acclimate to its new home better. So it's going to equalize that moisture content of what it currently has and the surrounding area. And then we're going to stack that product up, whether it's lumber siding, trim, flooring, you name it. We're going to stack it up kind of like a pyramid. And that's going to allow the water to run off of the top and not pool, because it will pool. And a lot of that moisture can then go through that tarp into your board. So we want to make sure that we are storing it. Now, like I mentioned, the fasteners, please specify how you want the specific products to be stored. It can avoid a huge problem in delays. So moisture content is a very easy thing to check. A moisture meter, they're roughly $10. You can get them all over the place. And they function by you having two electrodes that are going to be poked into the material, and it's going to set a current between the two, and it's going to measure that resistance, and that's going to give you a good approximation on the moisture content. And that's important because, remember we talked about, as lumber and products are going to increase in moisture, they are going to increase in size, and as they dry, they're going to shrink. So we want to make sure we're not installing something that's got too much moisture, because once you install it, it may shrink and leave gaps and no longer really be the right install. So anything for exterior applications, really above 18%, I would recommend not to install. Now, if you store it properly and let it air out, it will acclimate to its new home in just a couple of days. Now, this is a neat chart because this is talking about the actual percentage difference in moisture content you're going to get compared to relative humidity. So if you look at a 25% humidity, you're talking 5% moisture content in the wood, and that goes all the way up. Now, when you see 99%, you'll notice that it tops out at 23 to 30%. And that is because there is only so much moisture that those cells or those straws in that lumber can hold. So that's really where it's going to top out. This is an interesting map because it's just showing a relative humidity map just to drive the point home that different areas are very different in humidity. And especially in our modern age, many architects can be building and speccing projects across the United States and across the world. So very important to know where you're going to be and design accordingly. We talked about nailing a little bit via nail sickness, but we're going to drive that point home a little further. Let's make sure we're using the proper fastener for that product. Now, where that can be really important is there's a lot of wonderful synthetic composite products out there that are very specific on the type of fastener. So we want to make sure, once again, that we are specifying that fastener so we're giving our builders the best chance to install this properly. Now, I've looked at this picture a million times, so I know what that little image is on the circle on the left. That is a nail that's been overdriven. So it may not seem like much, but an overdriven nail is just a little pocket to hold moisture and water. And over time, not just for wood, but a lot of other products, that moisture is going to seep into the product and could cause premature failures. Now, there are plenty of products that are treated for exterior use, but it's only what we call an envelope treatment. So that is just the outside, not the centers. Once you've opened up the exterior, you can cause a problem for water intrusion. So using a good exterior wood putty, depending on the product, if it's a composite or synthetic, find out what is the appropriate filler and make sure we use it. So next we got the 5 Ds of building durability. The design of the project has so much to do with making it lasting. And all these different areas, and this is just a few, that need to be taken into consideration on how we're going to design, how we're going to build, that we are thinking about moisture in a sustainable, long-lasting exterior envelope. So designing according to a region. You may have someone, for instance, I'm in Florida, and they may really want more of a Santa Barbara style home, or what we see here is an arid style. That's not always going to work here. So if you're going to design a different style for not necessarily the appropriate environment or appropriate region, we want to make sure that we're using the right products to do our best to mitigate that. Because so often, from an architect standpoint, is you have the way that it should be done, you have what your client wants, and you've got to be the magician and find something that works in the middle. The next thing we're going to talk about are not only what I recommend as a Windsor One manufacturer, but these are industry-wide best practices. The things we're going to talk about today, they are what many of the fiber cement manufacturers recommend. This is really the way that you should build, and it's also what's on their installation instructions as well. So deflection, we want to get that water, that rain, whatever it is, we want to give as much of it as possible to deflect away from the structure. And a lot of that can be done through flashing and having the appropriate pitch on some items. Now, when you look on the picture on the right, you're going to see it's pitched at 30 degrees. That's going to allow that water to run off without pooling. If you look at the picture on the left, you're going to see where that water pools. Now, what I will caution you on is there are many amazing products today that will tell you that it's okay to not pitch their product because it's impervious to water and moisture. Now, that's great, but what's not impervious to water and moisture is the envelope behind it. That moisture will work its way behind the system, and the rest of that system is not impervious to moisture and water. So even if the product says it does not matter, it's still good to follow these practices. Little extra credit there for that, that groove cut in the bottom. That's just going to make it even harder for moisture to get up, around, and in. Flashing is another great way to get water away from our structure, but we want to use it properly. So we want that 30-degree pitch. And what a lot of people don't do is we need a 1/4 inch gap. And the reason why we need a 1/4 inch gap from the siding above it or the decking, whatever it is water can sit in that gap and surface tension. You know, think about knocking water over on a table. It's going to pool up. Now, if you've got less than a 1/4 inch of a gap, you run the risk of that water pooling and touching the material above and then wicking itself back up into the system. So I know we don't always want to look at the gap like we see on the right, but it's going to be much better to have that gap than a failed part of the project due to moisture intrusion. Now, caulking is a great way to seal off areas that cannot be flashed. But what's important is we want to use the right type of caulking. We want to install it correctly, and we want to maintenance it. So caulking is not a permanent solution. You know, if you think about a front load washer machine, there's that rubber seal on it. After a while, you got to replace that. So it's important to keep that in mind with caulking as well. It's not a you know, one and done solution. Now, when I talk about using the appropriate caulking, if you have ever been to a hardware store recently and you've seen the aisle that they sell adhesives and caulkings in, there are many, many types. And you'll notice that they are typically in either a PVC, you know, white PVC container or a foil-lined cardboard container. The reason why they're in different containers is because they can react with the container. So for instance, if you are using a PVC trim or siding, we want to make sure that the caulking you're using is not going to poorly react with that product that's going on. So just like the nails, if you're going to be using caulking on the project, please specify what is to be used. So when I say drainage, we're not just talking about downspouts, well, that's important, but we want to make sure that the water can get away from the project. So we look at this picture on the left, we've got that spot on the brick on the bottom without some mortar. That's going to allow moisture out. We've got our gutters that does a great job to get rid of that water. Often with gutters, we forget how important it is, though, is on the bottom of that downspout. We want to make sure that water is getting away from that building. It's a great way to flood basements or undermine a foundation from just years of just having water pour out in that spot. So diffusion is a tricky one. It seems kind of counterintuitive, but we want projects to breathe. And this is a great example. Well, a very bad example, but a good example of what happens when something was essentially buttoned up too tight and the moisture had nowhere to go. When you think about your house, we've got kitchens and bathrooms, showers, all the appliances, all these things that introduce a lot of moisture inside the home. That moisture needs somewhere to go. If you don't give it somewhere to go, it's going to find it. And that's what happened here. Too much trapped moisture inside the home. It could not breathe. And it eventually pushed itself out the siding and peeled the paint off. So very important, give some room to breathe. And when I say room to breathe, a simple gap between your siding, between the plywood, is going to allow moisture to evaporate out the top and water to drain out the bottom. So if you don't have that gap, you're going to run the risk of trapped moisture, which is, remember, not what we want. We want to allow breathing room. And there are so many wonderful products out there today for this that are very cost effective. It has just become the right way to build, whether you're going to use on the right some pressure treated plywood batten strips, or you're going to use on the left. This is a specific product by Benjamin Updike that's just going to give you that gap. Obviously, if we're adding something to our envelope, we want to make sure that we're not going to impede on all of our thresholds and our windows, our bump outs. We're accounting for that. But build this in. It's a great way to really save on the project. Exterior columns are typically the first thing that's going to go if the project really wasn't done properly. And it's just because there are so many things going on with an exterior column that if not done properly, it's going to be kind of your first alarm bell that you probably have some other issues. So a really big one is we want a 2-inch gap off whatever surface that column is on, because it is going to just suck up moisture. And when you think about a column, like I said in one of the beginning pictures, it is typically a structural 4x4 or 6x6 piece of timber that often has been pressure treated. So it's going to be very, very wet from the process of the pressure treatment used. Now, that's going to mean as it's installed and over time, it's going to dry, which means it's going to shrink. So by installing properly and giving that room for that timber in the middle to breathe over the seasons and acclimate and change, you're going to keep a nice, beautiful looking column for a long time. Now, also, I like to encourage people that sometimes it's good to mix products. So while they may want a beautiful cedar wrapped column at the very bottom, maybe it's a good idea to use some PVC for that spot, just because you know that area is going to get hammered. So don't be afraid to mix and match where appropriate. And I know 2 inches off the bottom can really not achieve the look that a lot of customers want, but it's going to allow for a long-lasting installation. So these numbers are important: 6 inches, 2 inches, 1/4 inch. Now, we already talked a 1/4 inch, but we're going to jump into the 6, and that is ground clearance. So we want a minimum of 6 inches of ground clearance above dirt, grass. And what that's going to do is just going to mitigate some of that moisture, insects, a lot of things. This is just a way to do it. And like I mentioned, many of the siding applications or manufacturers, trim manufacturers, this is what they recommend, 6 inches. Now, where that gets tricky is you think about a deck or your patio, that is falling on what we call it, same as our roof clearance, that's 2 inches. And what the main reason for a roof, we want that 2 inches, is you're getting all this runoff. And we've got flashing, we have all these great things we've done to get the water away from the building, but we've really not done much to stop water from splashing and going vertically. So if you don't leave enough of a clearance, you run the risk of all this runoff hitting that edge of your trim and then splashing back up into your system. And a lot of times you may have this leak presenting itself on a window that's on the other side of the building. So very important that we're taking care of this in the beginning. We've already talked about that 1/4 of an inch, just driving that point home. We want to use that 1/4 inch to stop that moisture from wicking up into our system. Priming all of our end cuts. This is that bundle of straws. That's where the moisture is going to move. Fiber cement manufacturers, synthetic wood manufacturers, they want you to do this. When that product is cut, you're exposing the core of that board, whether it be wood, fiber cement, you name it. It is a good idea and a best practice to just cover that up. And it doesn't have to be a high-end exterior paint. It really just has to be a primer. It's not to protect it from the sun. It's just to slow down that moisture. Now, when we want to increase the durability of our wood projects, there's some easy things we can do. Historically, we're going to pick durable wood species like cypress, redwood, cedars, beautiful trees that have a lot of natural built-in defense to rot and insects. Now, there's some limitations to this. So when we look at this picture, you're going to see we've got labeled as heartwood. Now, the heartwood is the center of the tree where those bundle of straws have essentially stopped functioning to support the tree, meaning that all those sugars and water that keeps the tree alive are not going to be in those straws anymore. Those have been replaced with minerals from the ground and resins, and that's going to allow that part of the tree to really handle the weather very, very well. Whereas the outside of the tree, that sapwood, that's really what's keeping the tree alive. Now, the issue you get with this is it's very hard to get these trees. We're not really cutting down these beautiful big old growth trees anymore. And frankly, we shouldn't. So we're talking about these old growth trees that are 200, 300, 400 years old. And we're not just, you can plant them, but they take a long time. So that material is very limited in availability nowadays. So when you get cedar and cypress, a lot of times it's only in that in name alone, and the performance isn't like we remember. So what are we doing now? We're moving on to what we call new growth or second growth. These are trees that have been planted and farmed. Think about an apple orchard or a grape vineyard for wines. A certain species is selected, planted in a certain climate, and going to be allowed to grow to a certain point. Typically, it's about 25 years, and that tree is going to be about 25 inches around, and then they're going to harvest those trees and turn them into any number of products. Now, things are a little different, though, with that, is because these trees are smaller, we've got to cut them a little differently. Now, when you look at the picture on the right, that's called quarter sawn. On a much larger tree, you're going to cut it that way because those rings in the tree are going to be in such a way that it's going to keep that board a lot more stable. Now, we can't really do that on these smaller trees because they're just too small to cut that out of. So when we end up doing that, you end up getting different pieces of the tree move a little differently. So when you look at quarter sawn on the left, that's ideal. But mainly what we're stuck with now because of these smaller trees is going to be plain sawn, which is that piece on the top. Now, there are ways around this. We're going to do what's called finger joining. And what finger joining is going to do is we're going to take that big piece of lumber, we're going to cut out all the knots, the sap, all those imperfections, and we're going to be left with smaller sections of wood that we're then going to mill a pattern in it, like fingers or teeth, and you're going to glue those together and push those pieces together. Now, what that allows you to do is take really good stable cuts in smaller pieces and glue them together to make almost whatever width or length board you would need. So that's going to allow these younger trees to give you a very stable product. Now, increasing the durability of our wood trim, besides just picking a good species, we can also do some man-made treatments. So some of these you've heard of, some of these maybe you haven't, but let's talk about borate. Now, borate is a great treatment method. It's very safe, so it's good for interior use. There's a lot of things we like about that. It's not going to have a smell, non-corrosive, so it's very welcoming to a lot of different types of fasteners. But the issues you start to get with borates is they're not great where product is going to be wetting and drying. It can leach out. So that can be an issue. The effectiveness over time gets drastically reduced. Next one we're talking about is copper azole. So that is when you hear someone say pressure treated, this is going to be the lumber is going to be put into a vat. A lot of times there's going to be little stab marks they call incise marks, and then it's going to be put in pressure and it's going to force that treatment into the lumber. And this is a very, very effective way to build, to treat, and you can change the concentration as well. So if you are just building a deck, you can go with a lower level of treatment. If you're making a pier for a big marine piling for a pier, you can drastically up that treatment to get that to last. On the con side, though, it is not safe for interior use. Do not use this interior-wise. Due to those high levels of metals in this process, it can be very corrosive to fasteners. So very, very important. Spec the right fastener to be used when you're using this type of treatment. Also, it does not penetrate the heartwood. So the center of the tree, if you have any of that beautiful heartwood in there, it's not going to treat that. It's going to be on the perimeter. So it also happens when you've got a larger piece of lumber and you cut it, it's going to be exposed. You'll see that the center is not treated. So next one, LOSP. This is a solvent vacuum pressure. So they're using 2 fungicides and 1 insecticide with the preservatives that are insoluble in water that's going to really help them stay where they're at. So it's a pretty neat system. Instead of using pressure, it's a vacuum. So they're going to use a carrying agent to pull, and with that vacuum, those preservatives and fungicides and insecticides inside to the center of that, or inside to the wood. Now, the problem with this, though, is it is not going to be safe for interior use. It's got some volatile organic compounds, so we don't want to use this inside. From a cost perspective, it's great, but from safety and environmental concerns, that is the trade-off. Also, it's not going to penetrate the heartwood. Now, this can be an issue because on a 16-foot long piece of lumber, you can expect an upwards of 30% heartwood to be in that. So you're talking about 30% of that lumber that's not treated. So that can be an issue. The last one we're talking about is TrueCore. And if you can't tell by all the pros, this is what we use at Windsor One. It is a borate-based treatment, but we've done some cool extra things to it to get it to stay where it's at. But what we like about borates, remember, safer interior use. So the TrueCore system, you can use this treated boards interior, exterior. A lot of projects, the kitchen may run into the backyard patio and they want it to look the same. Or we don't want to run into the issue of the installer accidentally installing the treated material inside or vice versa. So this allows you to just use one product for all. Very safe indoor air quality rating, safe for the environment. It is treated to the core of the board. So it is not an envelope treatment. It's going to get the heartwood. It's really one of the great systems out there. So our weather resistant system is the name we've kind of dubbed to the extra things we've done to keep those really effective borates in the wood where they belong, inside those straws. And what that's going to do, it's going to minimize the effects of water, and it's going to drastically minimize water absorption. And it's going to give you a much better paint. So when you think about when you first put paint on something, a lot of it, that moisture is getting sucked right into that material. And now you've got to add paint over the top of it. So we're going to have better paint adhesion. reduced moisture absorption, and a much less effects of water. Now, on the con side of it, I had to put something. So this is a water-based treatment. So you do need to allow it the time to dry and get that moisture out. This is going to be done by any reputable manufacturer at the manufacturing facility and will not be an issue for anyone on site. So your takeaway here is I really want to put wood back on the menu for you all. If you're going to want to use some beautiful lumber, people love the look and feel of wood. And if you pick the right manufacturer, you pick the right treatment, you install it properly, we can get back to using these beautiful products on our projects in an exterior application. From a Windsor One side, we have a lot of services available for architects and designers. Our idea gallery, getting samples. We know that this can be the hardest part of getting a product spec is not being able to get your samples, get your designs to make that easy. So we take care of that. So our boards, always smooth, always tight and clear, consistently true. We use technology to make Windsor One boards really like they used to be. So I appreciate you all listening in and learning about Windsor One. If you have any other questions, I know I'll be getting those from you guys after, and I look forward to answering them. Thank you very much.
Thank you, Bill. We will have a few minutes for Q&A. We have one question from Adam. Adam is asking, how can we avoid wood shrinkage in residential construction?
So avoiding wood shrinkage in residential construction goes so much into making sure that product is acclimated properly in the beginning. So when you get that product, we want to store it like I mentioned, let it acclimate to its new home. It can be very common for something stored at a lumber yard in bundles to retain a lot of additional moisture. It could get rained on at the job site, and because they're all stacked together, they're going to retain all that moisture. So we want to let it get ready. So you to its new home. Use a moisture meter. Use a moisture meter. Refer to that percentage of relative humidity versus the interior moisture of the board, so you know that it's ready to be installed. And then, use the best practices that we went over today to make sure that when something does get wet, it's able to dry out and kind of stay in that magic number where you want it.
Awesome. And we do have a couple of poll questions that we can launch since we still have some time. Let's go ahead and launch the first one here. The first one is here. What material do you normally specify for exterior trim? And we'll give you about a minute to answer that. And if you have any additional questions, please use the Q&A panel and we'll be glad to answer them with the time that we have. Bill, love the shirt as always. Always have a great selection.
I try. I'm on the road today, so I didn't wear the one that I really wanted to. I have a blazer that would crack you up.
Oh,
maybe next time.
Yeah, maybe next time. Looking forward to it. All right, let's go ahead and end this first poll and share the results. We have 30% wood, 30% PVC, 28% fiber cement, 10% modified wood, and there are 2% other. And the second poll. What is the number one cause of all wood insulation failure? Is it second growth wood not being as durable as old growth? Is it man-made treatment failure, or is it poor moisture management? A few more seconds for that. All right. right. Thank you for those who participated. And majority are reporting poor moisture management. That's correct, right, Bill?
All right. Good job, everybody.
Perfect. Well, Bill, we do not have any additional questions. Once again, thank you again for an excellent presentation as always.
Thank you for having me. Have a good day, everybody.
You too. Appreciate it. Here is your next session code, everyone. 137196. 137196. Also available in the webinar chat. And I just want to do a quick follow-up from the previous presentation with Dan. Just want to go back to a slide here. When you're submitting your, because Dan is offering samples with AdFast. This was for building facade glazing. So if I come back here, when you submit your session code and you go to the next screen here, you have the course survey, which is 6 multiple choice questions and 1 open-ended question for presenter feedback. You do need to provide feedback in order for your session code to process. And in this case, Dan offers sample. So if Dan offers sample, you have an additional question in the course survey. So you can submit that in the course survey. And once you're done, hit the confirm my presence button. So just wanted to clarify that. You can also use the Q&A as you've been using to request, but you can request it right here in the course survey as well.
Hey, thanks, Fulgence. Appreciate it.
My pleasure, Dan. Good to still have you here. All right. Okay, so we are at a break and we'll be back at 1 p.m. And if we can get our next speaker in a little bit earlier, we'll try to start a little bit earlier than that, but I'll try to get him in a little bit. So let's see if we can do our 15 minutes and we'll try to get our last speaker in a bit early so we can finish a little bit earlier. So hang tight. See you soon. Enjoy your break. I will do a 15-minute break. All right. See you soon. Hello, everyone. We are back from break, and we're going to move on with our agenda for today. Here to present the benefits of 100% off-site fabricated stainless steel railing system. Please help me welcome Mr. Kevin Harris from AGS. Kevin, how are you? Oh, you're muted, my friend.
Mute. There we
There you
go. I'm very well, thank you.
Very good, very good. I didn't
Welcome,
stump
everyone.
on the title this time. I didn't stump on the title today.
You're getting better and better with
Better and
each
better.
passing week. Okay, let's see if I can share. Share. Bolton, does it look okay?
Yes, you're all set. Take it away.
Perfect. Check my timer. Great. Well, welcome everyone to this part of today's presentations. My name is Kevin Harris. I'm the Director of Sales and Marketing with AGS Stainless. We're a custom railing manufacturer. We've been in business about 40 years. I'm also the immediate past president of the AIA's Custom Residential Architects Network grant. We have a big event coming up next month in Alexandria. If you're interested in residential architecture, come and check out our agenda. I'm also the past chair of the National Association of Home Builders Leading Suppliers Council. That's about 130 of the most recognizable architectural product manufacturers in the world. So I'm working in national leadership with both the AIA and the National Association of Home Builders. This presentation today, I think you're going to enjoy because we're going to be talking about a component of a structure that is very, very visible. It's one of the most visible parts of every project. And it's a place that sometimes gets overlooked. And rather than highlighting the tremendous visual potential of this component, railing, projects, because they tend to run out of money, go with something that's just functional instead of something that is both functional and artwork. So we're going to talk about a way that you can include more custom railing in your projects and deliver a value proposition that allows it to stay in the project even when you get to the end of the project and you're out of money and you're doing adjustments to try to fall in the budget. So we're going to talk about how to deliver very high visual impact custom railing to the project, but have it be truly affordable. I'm going to show you a number of images and as we walk through the presentation to just help to make the point that it doesn't matter whether you're designing commercial projects, residential projects, institutional projects, educational projects. Railing is typically a part of most of those projects. And when you are including railing in the project, if you can go with stainless, you're going to deliver a much more visually impactful solution than if you're going with the other commonly used railing materials. This is this was the before image of a condo project in Santa Monica, and probably built around the 70s, I would say, right across from the ocean. So this is what you got. Now they replaced all those railing with brand new custom stainless railing. What a tremendous difference in visual impact. This is a hotel in Palm Springs, the Thompson Hotel. They use the stainless railing for the balconies on all the suites. Gives you just kind of an overall idea of just how visually impactful stainless railing can be when compared with the other commonly used materials. This is a private residence in the San Juan Islands in Washington State. Beautiful area of the country. Here the builder, this is a modular builder. Their name slipped out of my head. They prefabricate, Method Homes. They prefabricate the home and they ship it out to the job site ready to be installed by a local contractor. Prefabrication, as you probably are all aware, is a growing construction method in the industry. So we've got custom stainless railing there with glass infill, but you can just see like the stainless railing just calls out to you, and you're just adding visual impact to what is already a beautiful home. The other materials just really can't quite do the same thing. This is a private school in New York area, Poly Prep Country Day School, really nice facility. These are the exterior stairs, fairly complex. Here are the interior stairs, fairly complex. We did this project, but we never visited the site. So through the off-site construction process, we're able to deliver railing that is componentized, numbered, completely fabricated. So no on-site cutting or welding or grinding or polishing. The components of the railing system are shipped out to the builder, ready to be installed with just a few simple hand tools. So the technology of being able to prefabricate the railing and ship it out ready to be installed is very powerful because it both reduces the overall product costs, but it also improves the quality of fabrication, and it drastically shortens the time it will take the builder to install the railing system because everything's all laid out and numbered. So when you're looking at the easy to follow installation instructions, it says all the posts numbered like this go here, all the posts numbered like that go there. So again, 100% offsite fabrication really helps the builder, because the number one challenge facing the construction industry right now, it's not tariffs, it's lack of skilled labor. So I mentioned to you that I'm in national leadership with both the National Association of Home Builders and the Custom Residential Architects. With the National Association of Home Builders, we run surveys each year in the construction industry to find out what challenges are facing builders. And for a number of years now, this has been the number one challenge, lack of skilled labor. So to the extent you're able to include architectural components in your projects that are 100% prefabricated, built off site and shipped to the job site ready to be installed, you take a huge burden off the builders because they can use less skilled labor to complete that part of the project. So like with us with custom railing, a local fabricator, 10, 20 years experience in the business, they can build anything out of metal. Those are very expensive professionals, and it's becoming harder and harder to access them in the market. Where when you have all the railing prefabricated, it's a completely different construction process, which then results in product delivered to the job site that a completely inexperienced person can install with a few simple hand tools. So you make it easier for the builder to complete your project. So as we go through this, I'll be talking about a custom railing, but you can apply the principles with other components in your project, that there is a prefabricated option as opposed to a very skilled, very expensive local professional doing a lot of that work on site. Outdoor application here, powder coated. This is a private community in Florida, Lake Nona. Residential application here for custom stainless railing. This is a public marina. So again, and look at all these different images. The point is that regardless of what you're designing, adding stainless railing as opposed to the other common materials, aluminum, composites, etc., stainless is going to give you more than just something that keeps people safe when they're on the deck. Stainless is going to give you something that adds as much visual impact to the living space as a sculpture sitting in a corner of the outdoor area or a painting hanging on the wall. The advantage, though, is that you can use the railing, and your clients will every day. You can't really use the painting. It looks gorgeous, it has visual impact. You can't use it. The stainless railing will add as much visual impact as the painting, and people will use it each and every day. And so I'm going to skip forward through a couple of these pictures and jump right into the content. We're going to break down the railing system. We're going to talk about the materials, and we're going to talk about the components of a typical system. Starting with materials, the most common material used in railing is wood. So again, with the National Association of Home Builders, we survey the builders at least every 2 years. And wood has been at about 50% of the market for some time. Next comes composite materials. They are rapidly growing in popularity. That's Trex, AZEK, Moisture Shield, all of the composite manufacturers. A lot of them are traded on the New York Stock Exchange, big, huge companies. They're making their product from recycled carpet, recycled tires, and a lot of different things. Very popular because they're pretty low maintenance. When it comes to metal, the most common metal used for railing is aluminum. It's the go-to metal for most builders, and it's usually the builder that's installing the railing on the project. Aluminum is very easy for the builders team to work with. You buy the components and stock links. You pick it up at the local lumberyard. It's very easy for the install crew to cut through the aluminum, attach the components, typically with some adhesive, maybe some screws, some mechanical fittings. Aluminum is the most popular metal that's used for railing today. But when you look at this image, you're looking at all stainless, marine grade stainless railing. This project was built by a design build firm called Sustainable 9. And it's kind of an interesting story because the builder visited a home that was pre-built at the International Builder Show. So outdoors of the Builder Show in Vegas, all these pre-built homes go up. The builder toured that home, and he got to talking with me, and he said, you know, I like the railing that you have in this home. He said, I'm building a home in Minnesota, and we're on the Street of Dreams. And if you know anything about the homes on the Street of Dreams or the New American Home for the International Builder Show, any of those things, they have a super tight timeline to get the home built. So that was the case with this builder. And he said, so Kevin, I wonder if you can help me. He goes, because I want stainless railing, custom stainless railing on this project. He said, but all of the fabricators in this community are all working on the new sports stadium. So we can't get anyone to come and fabricate the railing. So to make a long story short, we worked with Ryan. We shipped his railing in about 3 to 4 weeks. I think it was closer to 3. And he did not have anyone available on the job site that had any railing experience. So he had his drywall installers, who weren't busy at the time, install all the railing. And it turned out absolutely gorgeous. I had him on a presentation we did at Dwell on Design in California a few years ago. And he told me, he said, Kevin, we only had a few weeks to get it done before the Street of Dreams opened. He goes, everyone who walked in the front door of that home. So what you're looking at here is just inside of the front door. He said, everyone who walked in the front door of that home walked immediately over to the railing and start rubbing their hands on the railing and say, this is absolutely gorgeous. That's what you get from stainless. Just think about high-end kitchen appliances. If there's a metal on the front of a Sub-Zero refrigerator, what are the chances it's going to be aluminum? You're probably thinking 0, and you're right, because the aluminum doesn't have wow factor. There is metal on the front of a Sub-Zero. It's going to be stainless steel, because everyone who walks in that kitchen is going to go, wow. And it's the same thing with railing systems. So again, we're going to be talking about how to add custom stainless to your project and have it be more affordable and easier for the builder than relying on the local fabricator to do this work. So again, comparing the difference between, well, actually, before I do that, I've got a few questions. Fulgens, can you ask the first question?
Yes, absolutely. One moment here. There's something that's sharing. I'm just trying to end it. One moment, Kevin.
Okay. You're eating into my time though, Fulgence.
I know. There is a poll that's still being shared or something that is not letting me launch these polls. I'm just trying to see where it is. There it is. Stop sharing. Oh my gosh. Okay, here it is. Perfect. How often do you include off-site fabricated products in your projects? Give you about 20 more seconds. Okay, so Kevin, we have 54% often, 38% sometimes, and 8% have not yet.
Those are great numbers. I'm giving you guys a round of applause because not all architects included prefabricated products into their design process, but this is a fantastic audience. And hopefully the 8% that's not doing it yet will get on board with everybody else. Okay, I want to talk a little bit about comparing the two ways of getting custom railing on your project. So number one, the traditional way is you specify custom railing, you leave it up to the builder to hire a local fabricator who will fabricate and install a railing system versus what we're talking about today, which is allowing a company to design, fabricate, and number the components and ship the components completely ready to be installed with no field modifications required to ship those components to the builder with easy to follow installation instructions. So those are those two options there. So when you have somebody local that you're relying on to fabricate and install the railing system, there's a couple of dynamics that you have to deal with. Number one, there's a huge difference in quality between the way one craftsman creates a custom product and the way another craftsman will create that product. That's important because you may be designing a project in an area of the country that you're not familiar with. So you don't really know who the great, super talented, meticulous metal fabricators are in that other state. And the builder may choose someone because they don't maybe have a good contact who's not going to do a very good job. When you're dealing with someone who prefabricates railing and ships it to the job site ready to be installed anywhere in the world, you can know what the quality will be in the product because it will be consistent. So that's a big, big plus. The other thing I mentioned just a little bit ago is you're developing a project in an area, but you don't know for sure that there's not one or two other big projects going on, which will suck out a lot of the potential fabricators from availability at the time your project needs railing. So when you're specifying that the railing is built off-site and shipped ready to be installed, you eliminate that issue. Oops. You also give the contractor, as you see at the last bullet point, the ability to install the railing with their own crew, not have to hire a local metal fabricator. Another big plus is when you're working with someone who is super specialized, which is the case with our company. We only do custom railing and we only work with stainless steel, so super specialized. You're going to get a better overall result than when you're working with someone who's a jack of all trades, right? We call local fabricators in the industry job shops because they can do anything with metal. They're building door hardware, hood systems, trellises, on and on and on. Whereas a company like ours, AGS, where we're just prefabricating one thing, railing, there's no railing challenge that we haven't dealt with many times. We've been doing this for 40 years. We can be just an excellent resource for your team during the design portion of the project. We'll provide engineering calculations, technical drawings. We can walk you through how other architects have dealt with challenges in their projects. So we can just be a really great resource for your team because this is all we do. Okay, we talked about the main materials. Now we're going to talk about the components. We've got posts, we've got top rail, and we've got the infill for the railing systems. Can you, Fulgens, ask that second question?
Sure. And there it is there. When including metal railing in your projects, which do you more frequently specify? All right, thank you for those who participated. So Kevin, we have 30% aluminum, 24% steel, galvanized carbon, other, and we have 46% stainless steel.
Awesome. So pretty evenly split. So for those doing aluminum and galvanized, I would assume that sometimes the choice is really just comes down to budget. I mean, how many of your projects at the end of the project, is there a whole bunch of money left over, right? It doesn't really matter who you're designing for. Pretty much all projects run out of money. And there's so many different railing materials that you can choose from, so many that are less expensive typically than stainless, that a lot of times it just comes down to value engineering and we got to come in under budget. But when you are talking to your client about prefabricating the custom railing, we'll talk a little bit about value proposition in a minute, but your value propositioning the railing early on in the process, because you're helping the client to appreciate that if you go with stainless, you're going to get the visual impact. And if you have all the railing prefabricated, the material cost is going to drop significantly, and the time it takes to install the product will drop significantly. So you're looking at the overall cost of ownership with the client. And once they see stainless, they will be on once you explain the value proposition. And that'll make it much easier to keep the stainless in the project. Even when you get to the end, even when you're out of money, you'll have the client fighting for the stainless because it's a property that they're in all the time, and they want to see the beauty of stainless as opposed to some of the less expensive materials. But again, we'll get to the value proposition of prefabrication in just a little bit. So we're going through the components of the railing system now. We got posts, top rail, infill material. Here looking at wood. Of all the materials, lowest cost of entry, but the greatest amount of maintenance. But wood looks fantastic. Sorry, gotta get the screen moving again. Look at a few examples of that. Just absolutely gorgeous, the things that you can do with wood, especially when you're complementing it with a stainless steel. You see a good example of that right here in this image. We've got stainless posts for the intermediate posts. We've got the stainless steel cable combined with the wood. Looks absolutely gorgeous. Same thing is true. I'll show you stainless posts, wood top rail. Absolutely gorgeous. So I'll have some of those images in a few minutes. But again, looking at wood, It's a great look, but outdoors, a bit more maintenance, but it looks really good when you're combining it with stainless components like the infill material. Plus, when you're doing the cable, you open up the view. When you're using just the wood pickets, the view is more obscured. Okay, installing stainless cable to wood posts is pretty straightforward. For the most part, the contractors just drilling holes through the posts and running the cable through. When you get to the end of the run, you need some way to tension the cable so you can remove the slack. Typically, there's going to be one in fitting that is stationary and one in fitting that is adjustable on each of the cable runs. There are a lot of different fittings. This is a very simple one, but very effective and fairly inexpensive. But as I mentioned, there's a lot of different options, whether you're working with stainless posts or wood posts or composite posts. The railing manufacturer can help you pick which of these components would be the best fit for that particular project. Next, we did wood post. Now we're talking about aluminum post. Again, this is the go-to material for most builders. You'll notice right away that the dimension of the post is small. Wood posts are typically 4x4. Aluminum is typically 2.5 to 3.5 inches in diameter, so a little smaller footprint. You'll also notice that the posts they have color. Aluminum is not a very noble metal, so if it's going to be outdoors, you're going to want to have some coating applied. The most common coating is powder coating, and with the powder coating, there's going to be some color applied. Black is the most common color for aluminum railing. Again, aluminum needs some kind of protective coating if it's going to be outside. One of the advantages of aluminum is it's a lot lighter weight than stainless. So if you're designing a really big apartment complex and you're dealing with weight considerations, you might choose aluminum for all the exterior balconies just because it's a lot lighter weight than stainless. But even in that kind of a situation, you'd most likely want to include stainless for the grand staircase in the main entryway or building for everyone, just because stainless is so much more visually impactful. It just sends this message of quality. And we'll talk a bit more about that as we move forward. Here you're looking at stainless in a commercial setting. This is the La Marquetta train station in New York. We did this project a few years ago. You can just see that the stainless looks gorgeous. And most designers know that. Most of the work we do, I'll say about 50-50. 50-50 of the work we do is because we're specified by architects. And architects understand the difference between functional, keeping people safe on the stairs, and functional artwork. And you really see that here because the stainless just absolutely pops. And again, we're focused right now on, excuse me, the posts and how they compare to the other materials. This is a restaurant in the South, a seafood restaurant. So you're just absolutely adding as much visual impact to the space as the art hanging on the wall behind the railing system. But you can't use the jellyfish. Stairs get used every day. And then we're looking now at composite posts. Composite posts are popular because they're usually added along with or offered along with the composite decking. And I mentioned some of those company names earlier. If you're doing an outdoor balcony, not balcony, but rooftop deck, you're going to be going with a composite material for the decking. It's pretty easy to say, yeah, let's just go ahead and do the composite decking, composite material for the railing. But I would suggest that you split them up. Yes, composite decking material is a great solution for a rooftop deck on this downtown building. But the posts can do so much more if you use the stainless railing, and the two go really well together. The challenge of the composite material posts for residential is that you can't really unify your interior and exterior spaces with composite posts because they're just too bulky. A lot of the composite posts are sleeves that fit over a 4x4 post, so they get bulky really, really fast, and they don't necessarily fit indoors, but just fine for outdoors. Anyway, so keep that in mind when you're designing those rooftop decks and you're using composite decking, that you don't have to go with the composite posts. You can see here this interior picture. One of the simplest ways to really revitalize an interior space is to pull out the old wrought iron railing and replace it with all new custom stainless railing, because it can completely change the look and feel of an interior space. Another thing that is going to be a big plus for you, if you're not commonly specifying stainless right now, another big thing that you're going to appreciate if you include more stainless in your projects is the ease of maintenance of stainless. So there are a couple of different primary grades of stainless in use. There's a whole bunch, but they're not the primary grades in use for custom railing. One is 304 stainless. That's what you'll see on that Peace Arch in St. Louis. That's 304. But then there's 316 stainless, which is commonly referred to as marine grade stainless. And at our firm, we standardized on that. It's the more durable, less maintenance required solution. Now, if you have been using local metal fabricators to add the custom stainless railings to your projects when the builder chooses someone, unless you've called out 316 stainless, 304 is a lot less expensive than 316. And since most local fabricators are buying the material they need for that job when they need it, they're probably going to go with 304 if you didn't call out 316. But 316 is a lot easier to maintain, and especially if you're designing a project in a high impact area along the coast, in an area where there's a lot of heavy industry, we recommend that you specifically call out 316. Now, stainless is super easy to maintain. If I was there with everyone and I said, hey, what's the most common metal in your kitchen? I'm pretty confident everybody would raise their hand and say stainless steel, because it's very easy to take care of. You use it, you wash it, you put it back, it's ready to go. And it's the same thing with railing system. It looks great. It's very easy to take care of. Before we talk about top rail, we're still on posts. This is a great opportunity for me to talk to you about something that's going to come up. So you're going to say, I love that presentation that it just did on prefabricating custom railing. I'm including it in my next project. You'll include it, and the contractor, whoever wins the project, is going to come to you and say, hey, I know you specified that company that does prefabricating of custom stainless railing, but I've been working with XYZ fabricators for years. They've done stainless railing for me for years. They're very good at what they do, and they're saying they can do this project for a lot less than that other company quoted you. When that happens, just tell the contractor that is great news. Have your fabricator fabricate one post for me, exactly the way they fabricated for my building. And then you can get a post from the company that does prefabrication of custom railing. And you can put those two posts side by side, and you can explain to the builder what you're looking for. So here's an example right here. So at our firm, because we prefabricated it, we can't offer you every single design that you and the project owner will come up with. If you have a client that says, look, what I want is an original work of art, right? I don't care how much it costs, but I don't ever want to see what I have on my building on any other building. So I want birds and I want limbs and trees. That is a project for the local metal fabricator, and they will thank you for referring them. To deliver the value proposition, which is what we're all about, right? Quality and delivering the value proposition, we standardize. And standardization is common with 100% offsite fabrication. So rather than saying we can do anything, but it won't meet our goal, right? So rather than offering you any post style you can dream of, we have two post styles. We have one where the post comes all the way up and we weld the mounting bracket to the top. And we have another one, which you can see here in this image on the screen, and I'll show you some more images of it as we move forward. This is a post with a stem reducer on it. So this is a very popular design style. So we cut the post stock short, the stem reducer is separate, and we attach the stem reducer to the post. Now, most of the time when you see this look, I'll show you the image first. This is what you're going to see. The post, and you'll see a line at the very top of the post all the way around, and then you see the stem sitting outside of the hole. So that top piece and that stem and the mounting bracket, which you can't see, is a separate component from the post itself. Now, fabricators have the choice of how they attach the stem reducer to the post. If you are fabricating to a very high standard of quality, you are going to weld the stem reducer to the post. And you remember that other picture, the stem actually popped out of the hole. If you are fabricating to the industry's highest standard quality, you are not using adhesives to make connections. So you see this stem is welded to the post. So you have the stem reducer in its entirety welded to the post, but then the weld was ground down and polished. So this looks like one continuous piece of metal compared to this, which is commonly used in creating this look where you've obviously got a piece that's failed because the stem is outside of the post. And you'll also see, if you look at the post in the background, it's out of alignment with the post in the front. So this whole thing is at risk of somebody getting hurt on the stair railing. So again, what we're talking about is how to explain to the general contractor what you're looking for. So number one, when railing is fabricated to the industry's highest standard of quality, connections are welded. They're not made with adhesives or screws. Some connections can be ground after they're welded, can be ground down and polished because there's not a lot of stress at that joint. So that's the case in the images you were just looking at. Other connections, you don't want to take away any of the weld because there's a tremendous amount of stress at that joint. So that's what we're looking at here. So this is the bottom of the post where the post connects to the base plate on a top mount application. So that weld that you're looking at there, that's called a fillet weld. And you see all those little puddles? That's a TIG weld. So with a TIG weld, what's needed is a lot more time and precision. The industry standard for railing welding is a MIG weld, M-I-G, not T-I-G. MIG welding is very strong and very fast, but it's not very precise. And many of the companies have gone to robots also at this point. So very strong, very, very fast to lay, but not very precise. So when you lift up the base plate cover on most metal railing today, you're going to see a big, thick bead of metal that goes all the way around the post, connecting the post to the base plate. You're not going to see what you're looking at on the screen. That's called a roll of dimes, and it's like having a roll of coins and you just spread them out with your thumb. That weld is a work of art. Now, most metal railing companies have an escutcheon plate, a base plate cover, because their weld is kind of unattractive. So if you, well, basically they know nobody's really going to lift up the cover, right? But we, at our firm, we have a cover because design-wise, sometimes it's a fit. But when you lift up the cover of our railing, you're going to see that, where any metal fabricator who comes to visit your client is going to look at that and say, wow, they really took their time on that. So again, all connections should be welded on railing fabricated to a very high standard of quality. And the weld should either be invisible where appropriate, or it should be a work of art, as you're seeing here. So when you're talking to the contractor and they're saying, we can get it done for less with XYZ fabricator, then the company that's going to prefabricate everything, get a post sample, put it side by whoever you're using to prefabricate everything, and they'll get it right away. And then you say, can they do this for less money? And they'll tell you honestly, no, because it's a completely different fabrication process, offsite fabrication versus a local fabricator. And I can best illustrate it with using cars. You remember before Henry Ford, everything was custom made and very, very expensive. And he came around and changed the fabrication process, right? So that's the same thing with offsite fabrication of custom railing. And it's going to be the same thing with offsite fabrication of other architectural components. So instead of having two guys with 20 years experience fabricate and install your railing, we have a team of people that works in design. We have another team of people that runs our fiber laser tube cutting machine, another team of people who do all the welding, another team of people who do all the grinding and polishing, and another team on packaging and shipping. So we don't need someone with 20, 25 years experience who are super expensive to do your railing. We just train people to do one thing, one part of the process. You do that, you do that, you do that. By the time your railing gets to the end of that cycle, it will look as good, if not substantially better, than the railing fabricated by the master metal workers. And it will be about half the cost. So again, getting back to that value proposition, when you explain to your clients early on in the project the potential visual impact from custom railings made from stainless steel, and you explain to them the value proposition of allowing someone to prefabricate the railing and ship it to the job site, numbered components, easy to follow installation instructions, ready to be installed with a few simple hand tools, they'll fight to keep the stainless railing in the project, even when they get to the end of the project and they're starting to get very, very tight on budget. So again, no on-site field adjustments, all the welding, grinding, polish, all done in a quality control environment. When a local fabricator is on site trying to dial everything in, if just the wind blows, it will affect the quality of the weld. So if you see a talented metal fabricator working outdoors, oftentimes they will have a tarp that they pull up over themselves around their equipment so that they can properly execute the weld. With offsite fabrication, all that work happens in a quality control environment where the fabricator is sitting at their bench, they got all their tools there, they're not dealing with challenges of trying to get their hand around something on the job site. So you're going to get a product fabricated to a superior level of quality when you specify 100% offset fabrication. Your product cost is going to drop, and you're going to drastically shorten installation time because everything's ready to be installed and everything's numbered. Okay, let's talk about top rail. I mentioned to you earlier that the stainless and wood together is beautiful. It's just a great look. The wood can soften the stainless a little bit. So we provide a number of different top rail options, which we're going to walk through here real quickly. But the wood top rail is my favorite. That's a by others. So if you're specifying stainless from us, we would prefabricate all the stainless components, but the builder will actually fabricate the top rail. And usually they're going to use the same wood that they're using elsewhere in that space. So you see that here, all the treads and the car decking are the same wood as the top rail. Just absolutely gorgeous look. Aluminum is an option for top rail. They're doing some cool stuff with aluminum. Like now you can have the aluminum look like wood. It's a great look. If you are going to use aluminum for the top rail, or if you're using aluminum posts, but you're going to use stainless cable, make sure when you're writing spec out that you require that there's clear separation between the two metals. And that's because you will accelerate corrosion if there's any moisture in the atmosphere. So aluminum posts, stainless cable, super popular today. I see a lot of installations and they have not cleanly separated the two metals. So that's very, very important. Composite materials can look good. Again, if you've got, for the top rail, if you've got composite decking and you're going to go with the stainless posts so that you're capturing more of the visual impact, but you want to go with composite decking, kind of tie, or excuse me, top rail to tie everything in. The issue that you have, the challenge that you have to adjust for is spanning the posts in an environment where there's a lot of heat, because you can get deflection. So you might want to run maybe like a stainless support on top of the stainless post and then put the composite top rail on. So again, the product manufacturer, whoever you're working with for the stainless railing, can help walk you through some of those things. And then there's stainless top rail. Couple different options. Our most popular for AGS, our most popular top rail is our flat stainless. Our products we've named Clearview because they're designed to look gorgeous when you're up close, but when you take a few steps back to completely disappear. So that's what happens with that stainless, flat stainless top rail. A few steps back, looking from your interior space outside, through the railing, 1.5 inch square posts, that whole system will just disappear and you'll be able to enjoy your green belt. You can see that in the picture behind me. As you're looking out at the green belt, the railing just disappears. But when you're up close, you can't help but notice the precision and the quality of the fabrication process. And then our most grippable handrail is the round on the left. If we're doing a commercial application quite frequently, we have the flat stainless as the top rail and the round as the ADA handrail. Here you can see round top rail, round ADA handrail. It's a good look. I'm going to flip through a couple of these images. Fulgence, do I have one more question or did I do them all?
Yes, we have one more.
Can you ask that one?
And here we go. What feature of an off-site fabricated stainless steel railing system would most influence your decision to specify it in? All right. Thank you for your participation. And we have 41% ensuring consistent product quality, 9% faster installation time, 34% creating a strong visual impact, and 16% reduced on-site labor needs.
Excellent. I guess I'll just focus on, not very many people said, faster installation time. I'll just take a moment on that. So once you compare, or let me say it this way, when you're comparing two different products that both keep people safe as they're walking up and down the stairs, keep in mind that without 100% prefabrication, installation time can really have can really drive costs on this part of the project. For example, it is not uncommon for an aluminum railing system with stainless cable to have more than 20 components that must be put together to build the railing system for that project. More than 20 components, right? That just takes time, right? Whereas when everything's prefabricated, there's only a couple components. So the installer can just get through that project. Oftentimes it's 50 to 60% less time than a non 100% prefabricated railing system. So if you're looking at total cost of ownership for the railing, how long it takes the builder to install it will definitely add cost to the project. So just keep that in mind. Okay, now we're going to transition into infill materials. The last of those three components of railing: post, top rail, infill. This is the largest part of every railing system. First, we'll talk about panelized infills. If your goal is to minimize to the greatest extent possible obstruction of the surrounding area, clear glass is the best fit. I'll show you some images of that in just a few moments. If that's not the driver for you, there are a lot of really cool glass options that you can use in your railing systems. So here we've got a railing system that does a great job of creating privacy. It can also be used to block the wind. So if you're designing a project that's got a prevailing wind, you can use glass to create a more comfortable space. So a lot of different things that you can do with glass as a part of your panelized infill options. Another panelized infill option is mesh panel. If you have not yet had the opportunity to work with the companies that create these mesh panels, Banker Wire, McNichols, I would encourage you to just go to their website and look at some of the choices. We love working with those companies. This is a Dave & Buster's restaurant. We got spec'd by Aria Group out of Chicago a few years back, so we're in a lot of the Dave & Buster's. This mesh panel is Banker Wire's product. They created the stainless U channel that goes all around it. And then we hold the U channel in place with those clamps. And the clamps are the same clamps we're using for glass and other panelized infill products. The architect had us powder coat the posts, top rail, and the clamps green. Again, powder coating is necessary with aluminum railing. It's not necessary with marine grade stainless railing. But as a design feature, it can really add visual impact to that particular space. So here you see it in green. This is a hotel in Kansas City. Again, this is a Banker Wire mesh panel. The architect had us powder coat the U channel, the clamps, and the posts black. And then the contractor fabricated the wood top rail. But you can see just how gorgeous that look is. So again, if you have not had the opportunity to work with the mesh panel manufacturers, I encourage you to go and look at some of the options that are available for you in designing railing for your upcoming projects. Cable is the fastest growing infill product on the market right now. I've been with Aegis, I think 11 or 12 years. There's about 6 companies when I started. Now there's pretty to everybody, probably 50 different railing product manufacturers who all have a cable infill option. So very, very popular, really minimizes obstruction of the surrounding area, and that's a plus. Here you see the posts and top rail are powder coated black. This is a great project in Lake Tahoe. This actually was ARC record House of the Month a couple years back. Cable is not powder coated, but we can powder coat the cable as well. All right, code requirements. Your product manufacturer will walk you through these code requirements, but the number one thing is a 4-inch sphere cannot fit through the gaps in the railing system. But again, the product manufacturer will help walk you through those. Rod railing. One of the benefits of cable railing is it disappears. One of the disadvantages of cable railing is over time, even if it's not settling, just gravity pulling on the horizontal cable will cause them to slack over time. And for some project owners, it's just a pain in the butt. Have to go around and periodically retension the cable. If you want to avoid that, consider specifying the rods or bars, rods, whatever you want to call them. They do not require periodic retentioning. And many people feel that the rods add more visual impact to the railing system. 5/8 diameter. I'll show you a few images of the rods. So no retentioning. And it's a very attractive look. Here you see we did the stainless top rail and the stainless as the ADA handrail. So keep in mind the rods have a lot of the same aesthetic as the cable, but they don't require retentioning. Okay, getting to the end here. A couple of things I want to say, and then we'll have a couple minutes for questions if there are any. Why should you work with someone who beyond prefabrication only does one thing, which would be us? The one thing is custom stainless railing. Because we are so specialized, we can invest in equipment that a local metal fabricator can't justify. So this is a fiber laser tube cutting machine. It's accurate to 4/1000ths of an inch. A local fabricator is not going to be inclined to spend the money on a product like this because they're building lots of stuff out of metal, right? Tables and like everything. We don't do any of that. We only do railing. And we order our material because the two post styles are derived from the same stock. We order our raw material in huge quantities because we only are doing these two post styles and it's the same raw material. So we can provide the 316 stainless to all of our clients without having to charge for it because we're buying huge quantities, right? This machine is so accurate where you're thinking about coming down the stairs and the cable is going to be running through the post. Typically, the cable won't stay aligned through the middle of all the holes down the post, right? When you're using CNC equipment. With this machine, we can make all the holes on the post elliptical. So they can easily come right down the center of every hole, right? Very, very difficult to try to do that with CNC equipment. So when you're working with someone who only does one thing, in our case, railing, you're going to get a product that is of higher quality, where we've taken the time to just dial everything in because it's the only thing we do. Another example is cable. Our cable is not just 316 stainless, it's electropolished. So we put our cable in a chemical bath and we run electrical current through it to knock down all the microscopic abrasions on the cable. And what that means is that when those microscopic particulates in the atmosphere hit the cable, they tend to fall off instead of being caught, which then keeps our cable more resilient to corrosion. And you can visually see the difference between electropolished cable and non-electropolished. So again, this is the only thing we do. We just are super meticulous on every part, trying to make it better and better and better. Okay, with that, I will take any questions.
Thank you so much, Kevin. We do have one question that came in earlier. Adolfo asked, in the instance where hardwood is used for the handrail, do you have under the wood plates to secure the corners and the plate-to-plate conditions?
You know, Fulgens, I got to turn up my volume. Give me a second.
Sure.
Because you came through really faint right there. Okay, can you ask me that again?
In the instance where hardwood is used for the handrail, do you have under the wood plates to secure the corners and the plate-to-plate conditions?
Yeah, so we weld a mounting bracket to the top of the post, and then the wood goes down, and then wood screws secure the top rail to the post. And if I didn't answer that correctly or not correctly, if I didn't actually capture the answer to what you're really asking, there is my contact info that Fulgens just removed. But anyway, he'll give it to you. Just send me a message, and I'll answer it, or I'll get our engineer to answer it.
Thank you. And if anyone has further questions, please do not post them in the webinar chat. Please post them in the Q&A panel. We have another question coming in. With prefabricated railings, how do you account for site variation and adjustments?
Yeah, I love that question. Thank you for asking it. We've been doing this for 40 years. There's no challenge in railing that we haven't dealt with many times. We've designed a process that allows us to work comfortably with the building, eliminating the need for the local fabricator to be involved. Builders prefer to just install with their own crew instead of hiring the artisan metal worker to come in and take over that part of the project. So what we do is we'll take the architect's drawings and we'll create a two-dimensional drawing, which we then send out, and it has balloons everywhere we need someone in the builder's team to capture measurements for us. The drawing comes back, then we create the final drawing, and we send that back to the builder to verify those measurements. They send it back to us. After we get that document back, then we'll go ahead and create the shop drawings, fabricate the product. So we've built this whole project out on paper. So all of the numbers are in our laser tube cutting machine. We fabricate the railing and send it out. The tile guy, he comes in, he lays a tile, and it's off. So the builder calls us up and says, hey, the post won't fit, the tile's a little bit high. So then we'll say to the builder, all right, don't cut anything. Take the current measurements, take a couple pictures, and send those to us. Because we have everything all built on paper first, and it's all in the computer, we'll then make those adjustments, refabricate those components that need to be, and ship them out to the builder. And that probably happens in about 3 or 4 days. We'll knock it out, ship those new posts out, and they'll go ahead and everything will turn out just perfect.
Kevin, thank you so much. No other questions at this time.
Awesome. Thanks for letting me present.
Thank you so much, Kevin. Excellent presentation as always. All right, everyone, here is your final session code, 137232. And Kevin's contact information is also in the chat for you all. 137232. Please make sure you enter all of your session codes at atsseminar.com via your ATS account. And let's see here. Okay, so Adolfo, can you please move that question over to the Q&A panel so we can make sure Kevin receives it offline? Please move your question to the Q&A panel. And if anyone has any additional questions for Kevin before we sign off, please add them to the Q&A panel and not to the webinar chat, because we have a Q&A report where the panelists can receive these questions offline and could respond to you directly. So thank you for that. And before we sign off, if you need any last minute credits, please visit the ATS On Demand course catalog at atsseminar.com. And we also invite you to follow us on LinkedIn. We have video updates weekly, and we have a podcast, live video podcast coming up pretty soon called Built for This. And our very first guest is going to be none other than Steve Gleason with Homosode. That premieres next Friday at 2:30 p.m. Eastern, live on LinkedIn. So please follow us there. I've added the link for you all to join in the chat. So we hope to see you there. And with that said, thank you all for attending our seminar today. I'll stick around to manage the Q&A panel. Once again, any last minute questions you have for Kevin, please add them to the Q&A panel and not the webinar chat so we can make sure he gets those, okay? And we hope you enjoy the rest of your beautiful day and would love to have you back for another webcast soon. Thank you, everyone, and peace.